So hey guys, my name is Raj. I hope the live is on. Here, so a quick intro about me. Again, I'm Raj. Basically, I've been working with a few enterprises. I would say I started off building startups, working on building AI agents on the legal space, and then pivoted to something else, and then started working with enterprises and basically essentially building RAG stuff, production RAG and AI agents for companies and mostly enterprises. And right now, even more specific to working with regulated enterprises like pharmaceutical companies, banks, and etc. So a quick intro about me, and I basically wanted to sort of do a live stream and show not really show, but then just take an approach of showing something raw on building something like this at scale. So I was using Claude to generate some test use cases and samples and scenarios, and I stick with one working with rocket science documents because it's very complex, not too much complex. It does have a lot of nuances, and we're also going to try to solve it at scale and etc. So essentially, we're going to build a rack system that works with NASA docs, initially starting with 10,000 documents, but then scaling to 85,000 and even more documents. We will try to solve uh, um, um, rocket design diagrams, formulas, and whatnot in a given documents. We'll go through the documents. I basically wanna, so for example, I've already created this scenario. Let me pull that up. So it's from Meridian Aerospace and etc. We'll go through that. So you can consider this as sort of like an RFP. RFP meaning like assuming that a company has sent me. So I'm just creating sort of like a fake scenario, but then this is how a real scenario would actually look like, and these are the requirements you really want to solve. And I want to start it raw, start it fresh, and just take an initial approach and see how far we can go with this. And I guess our goal is to in a couple of days or maybe even a couple of live streams, just complete the entire system that actually works with 10,000 docs, but in a way that uh, in terms of infra, it should also work for 85,000 documents, 50,000 documents, whatever the amount. And I will also go through, just give you some of the thinking patterns that I go through. And no, by no means I'm an expert at this. This is just an approach that I would do. And depending on each project's, the approach would change for the solution you build. When I started off, there was a lot of like we was writing a lot of custom pipelines and etc. Right now, you have a lot of frameworks, tools, and also models, better models to do document parsing and etc. So we'll just go through everything, right? And yeah, it's just an initial approach. If there's any mistakes or something like that, apologies for it. But we'll just try to we'll be natural. And I hope I could end of the day sort of we could sort of build this out, and I would have probably share the GitHub repo as well. So once this is done, you'll get the GitHub repo. You can check it out with everything. All right. So all right, let's get started, guys. So this is the use case I created. My classes. Yeah. So this is the use case that I created. It's called Meridian Aerospace. So we'll start fresh. This is how I would get a document from a company, sort of with all the correct all the requirements from a company. So I would first of all go through them, and we'll take it from there. So yeah, cool. So it's Meridian Aerospace. Meridian Aerospace is a mid-sized aerospace engineering consultancy company. So you have 180 employees. So it's quite a big company. And of course, if you see a lot of the research spaces, they like even though they only like, because for example, I did the POC for one science company. It's a POC, not a full-fledged product, but they had only 10 to 20 employees, but the usage was very more. So like meaning like it was a core problem for them. Something like that. So 100 employees should be okay, really. So that provides technical analysis for safety certifications for self-propulsion system. They work with both government space agencies and commercial launch providers. And you have the problem over 25 years, Meridian has accumulated approximately 85,000 documents, propulsion test reports, safety analysis documents, failure investigation records, component specifications, regulatory compliance filing. The span from scan 1990s. Okay, so you have documents from 1990s paper records, which means uh you have a lot of scanned stuff and a lot of tables that are scanned and etc. And engineers currently spend 4 to 6 hours per project searching through archives of to find relevant historical test data, failure modes, compliance precedents. Critical institutional knowledge is locked in heads of senior engineers. approaching retirement. Last quarter, they missed a relevant failure mode during a safety review because the historical data was buried in a 1997 documents. That's very true. A lot of this stuff do happen, I think. And most importantly, they have a lot of documents. These documents are, most of them, they're all local. Some of them is, most of the time it's actually classified, like they're very like protected information. It's not in cloud. Right now we're going to work with a lot of the unclassified documents from literally from NASA. We'll go through the code where you can pull like 10,000 or even more documents from NASA's website. But yeah, literally is that they work on a very like um, they work on-prem servers, to be honest. So um, they want something on-prem. But for this video, I'm going to use both on-prem models and also Claude and OpenAI, because there's a lot of other problems to solve. We'll solve that first and sort of switch up models. But initially, I want to do like I don't want to spend a lot of time in just hosting models and etc. Maybe end of the video we'll actually do the GPU part and manage context across processing documents. Maybe we'll like get a run pod or something like that and do it. But then initially, yeah. So I sort of get a sense of what they're trying to do. Let's go look at the document characteristics. So there's 40% scan copies. Yeah, we came through that. Heavy use of technical jargons, professional schematics, trust curves. Yeah, so there's a lot of technical, what do you call, technical diagrams, and I've seen this a lot. We'll actually go through them as well. Like in this, we'll literally go through a lot of them. Let's, for the first 1 to 2 hours, I don't think we are gonna code. We're gonna plan a lot of stuff. We're gonna think about things. We're gonna know the domain even a little bit more and try to understand what is this space and what are they really working on. Take like a first approach to the and solidify our understanding on the domain level, and then we move to the code. So the first 2 hours is like probably we won't be coding. Yeah, cool. And then you have the domain specific acronym. Okay, you have the domain terminologies as well. So ISP, TWR, etc. Yes, we do a lot of. I did some research on this as well. They have a lot of terminologies, and we'll actually solve that as well. So this is one. I can see that we have to solve for like 10,000 plus documents. Second, I can see is that they have a lot of scan copies. So meaning they have a lot of tables that's only scanned. So you PDFs, you can't literally pass like a single flattened PDF and you can't just process them. You can't process them as chunks. So we have to use a VLM for it to access the tables and etc. I can just feel what is going on here. And you have mathematical equation, you have a lot of formulas and etc. Again, here we need to use a VLM. There's a lot of tables. Yes, we need to use a VLM. And then cross-reference documents. Yeah, cool. So they have a lot of documents that are interconnected basically. So something that's how can I put it? Maybe something that's connected to each other. When you ask a question, it's not just around one document. It's probably like going through a lot of set of documents, and then trying to find an answer to a solution or something. And what they expect, yeah, NLP search, yeah, a search system that can understand, retrieve technical diagrams and not just not text. Yes, so it's heavily, so there's like 60% text and 40% of maybe the a PDF would probably have a lot of diagrams, and these diagrams are very complex. Should be able to pull that. Mathematical equation, okay, that's good. Okay, we'll be here. Legacy documents, okay, and engineers should be able to ask questions like what trust chamber failures have we seen in bipropellant systems operating in 2000 psi, and there's a lot, and get relevant historical cases with sources. And also guys, first of all, I have no clue. I don't have a huge clue on this domain. I've done a POC and done some similar work, but this system is something that I want to do really raw. And even though I have an understanding, I want to play as a dumb person and sort of use Claude as much as possible to understand what it really is. And for example, for this specific query, I would probably go ahead and ask Claude like what an actual human would do in searching and what the AI should do and etc. So really try to get very low, keep all the ego aside, and sort of really just from Claude trying to learn what the industry, what domain is and etc. and just try to solve this. And full on-premise deployment, yes. So I think at this stream, what I want to do is I've done this a lot. My work is on-prem deployment, to be honest, but I want to use Claude and OpenAI, and I also want to use some open source models as well, like an hybrid approach for this. And I want to, I don't want to stick to a what do you call, like a structure of doing things. So I just want to keep it flexible and sort of see what we can use and where it could, like I want to just flexibly build this out. So in case if in a real world scenario you want this to 100% air gapped, be a hair gapped and etc. You want to run this on an open source model, and we are going to use a lot of open source models for VLMs. For the agent, we'll start out with Claude and GPT. If we have time, we'll switch it to a open source model. But yeah, as long as we're using it through OLAM or whatever, as long as it supports the OpenAI spec, you can just switch up the models and it runs in your PC if you have a lot of RAM or maybe even GPU or run power and sort of get it going. And the budget range for it is like 45,000 to 7,000. But guys, in real world scenario, the budget is way more than this. I use Claude to generate this. I guess it's being a bit more generous on this, but $70,000 is really nothing for a rocket research company, I would say. They'll probably invest more time and money, both, and 10 weeks production pilot, but we're gonna do it in a couple of live streams. So maybe like, I don't know, maybe 3 7 hour live stream, 2 5 hour live stream or something. I don't know, but we'll just figure it out. We'll just complete it, but in a couple of days or something like that. I also want to verify if I'm okay. Okay, so the live stream is going on. All right, cool guys. So this is it. So initially, I'm just gonna go to Claude and I'm gonna go ahead and copy the entire thing, entire script, and sort of paste it. And so initially, I want to understand more about I want to literally understand more about the domain. Like, what is it? Like, what are we dealing with? Really, any background context that I would like to know for this specific requirement. So I would just say, just paste this. And I'll be like, new, please, please, what can I say? I'm new to this domain. I would like to know about this domain. Have a lot of unknowns, unknown unknowns, unknowns. Feel free to share. Feel free to share any what do you call any context or information. So we'll just kick it off. The initial thing, we have a project going on. We'll just ask Claude, what are we really working on? Just get a feed just on the basics of it and try to understand what this domain is. And I would also want to know. I also want to know more about the actual users of this system. Actual use this system as well. Okay, so we'll be like, I also want to know the actual user system, but then we'll send this as a second query. First of all, we'll just ask the general thoughts from Claude. I'm gonna go ahead and click on enter. Okay, Sanjay, நீங்க இருக்கலாம். No, Sanjay. No, not facing this above. Okay, yeah, he's my brother. Just having a conversation with him. Okay, so this is really interesting project. You're essentially building an enterprise drag retrieval for highly technical domain. Let me break this down on what you're walking into, the core problem you're solving. This falls under knowledge management or enterprise search, but specifically the modern AI enhanced version. Traditional keyword search fails here because an engineer searching for trust chain. Okay, chamber won't find a 1997 doc that says a combustion instability led to chamber will break. The concepts are same, but the words aren't. Yeah. So again, domain terminologies. I can have notion and note things down, but then I'll do it in a bit. What they want in a semantic search, finding documents by meaning, not by, of course, yeah. What you like to be building? Documents, a processing pipeline, a vector database, and a search interface. OCR for scan PDFs. We're not gonna do OCR, to be honest here. We're gonna use a VLM, and then embedding is metadata. Yeah, basic stuff. It's just giving you an initial understanding. Embedded, yeah, all of this stuff, basic stuff. Cool. The hard parts of this specific project. This is huge. Bad OCR, bad embeddings. Okay, again, we're not going to use OCR. I don't think so. This track, we're not going to use any of this. Technical diagrams are hard. Very true. Multi-model embeddings, somewhat match. Yeah. can describe diagram. It's a specialized. You may need to extract diagrams, captions, and embed those. Honestly, it might be a V2 feature, but we're going to do it anyway. Domain specific language. Yes, those acronyms are a problem. Generic embedding models are not may not understand them. You might need domain adapted embeddings. As we are starting with Claude and OpenAI, I've basically fine-tuned models on domain terminologies, and it's really a thing. It gives you a good boost in terms of search queries that the agent could run. But here I'm going to use OpenAI Claude. So because of that, we are going to take a lazy but still a very effective and a very strong approach, which is trying to do search, drag search inside of a vocabulary of domain terminologies, and then we pull that up and give it as context. So um, NASA has an actual website that has about 18,000, I would say more than 18,000, I think 18,000 domain terminologies, and we can easily pull that up and we're going to embed that. So don't worry about that. We're going to fetch docs, and both domain terminologies, NASA, it does provide a lot of resources, to be honest, more than what we want, really. Like 5,000 to 6,000 should be enough, but they have more than 18,000, I guess more than 20,000 domain terminology. So we'll go through them everything. So we'll go through everything. I'm just going on, just giving you a highlight on what we will go through as we move on. And cross-reference documents. A failure report references test data which references design specs you want. A metadata restriction, yes. Potentially a knowledge layer. This adds complexity. At minimum, surfacing related documents and results. Okay. On-premise deployment, yes, but of course we're going to use OpenAI embeddings and also OpenAI, or maybe I think we'll use Claude. I think we'll go with OpenAI for now, or maybe we'll use Claude. Whatever, we'll see. You'll need local embedding models. Okay. Yeah, I think we'll run. I didn't think about embeddings. We'll use OpenAI. There's also other very good open source models. We might use a re-ranker. I'm thinking of using ranker from. But still, we'll just figure it out. Let's see. If you're using a BLM for answer generation, doesn't matter. Okay, so and this is the most important thing, I think. So we'll go through this. The aerospace domain. So you understand what you're building. Bible system rockets using two chemicals, fuel and oxidizer combined together. Fuel. Some of the stuff I just can't even spell. What's this mono method? I don't know. It's MMH, okay, and it's NTO and it's LOX. Key metrics engineers care about efficiency and okay. So these are jargons. Like from day one, even I can't spell this. These are like really it's standardized jargon. Like you can't invent this. Hopefully yes, and like they have very standard sort of jargons, which makes our lives even more easier because if we know what the jargons are and if it's the standard, we basically are 99% there of using that terminology search documents. It's probably going to be the same thing. Like LOX would be LOX in every document. And if the user were to ask something on not space, something on the liquid oxygen, you probably could convert into LOX or whatever, any terminologies that could match on that specific query, and then we can go ahead and search it up. Yeah. So why historical failure data matters? Aerospace is heavily regulated and safety critical. When certifying a new system, you need to show you've considered all known failure modes, missing historical failure, and the last. Okay, so I'm just gonna go through this a bit, and of course you can also go through with me. I don't want to just keep on talking because afterwards, as I move on, probably be thinking a lot and just and then do stuff. So probably be less talking as I move on. But yeah, you can follow up. You can just follow through the things like here. Like just go through this. Okay, yeah, that's not the best um intro, but yeah. Um, Cool. And also the questions, yeah, these are relevant questions. So once I go through this, and guys, this process takes a lot of calls, guys. Even though we jump straight away to the code, we don't jump, sorry, straight away into the code. There's a lot of stuff that goes on here. We essentially, what do you call? We essentially have weeks in calls. That, to be honest, not weeks, maybe a couple of weeks easily on calls. we try to understand as many details as possible. For example, you can see, can I get sample documents? Yes, we already have. So of course that's solved. What does a success look like for a pilot? Very good, very good. This is a concept that we ask because it's very easy to put that up saying, you need to build rack for this. And the assumption is very, very different. For example, at this stage, at this point in time, we don't have models that can read 100,000 documents, right? Like even though we support 100,000 documents, our models are not gonna read 100,000 documents to come up with an answer, like to an accurate answer. Like it doesn't need to. The initial, the real idea is that you have 10,000 documents, 20,000 documents, 30,000 documents, 40,000 documents. It doesn't matter. On a given query, the agent would only need to read maximum 40 to 50 documents, right? That's it. And 50,000 documents, 60,000, 70,000 documents is actually an infra problem, and also and a problem of relevance, not a problem of agent. So essentially what we're trying to do is that, again, a needle in a haystack sort of a problem, where you have 40 documents that is relevant to this particular user's question. You just need to find the right 40 among the 100,000 documents. That's it. To be honest, it is complex, but it's not as complex as it sounds. Like it's not going to read 100K documents. Like it just can't read that. I don't think, if the documents are even long, I don't think the AI could even read 40 documents. If it needs to read the entire document, maximum it could go, I'll show you the documents in a bit, we'll go through them, but it'll maximum go through and read, I would say less than even 20. Like rocket science documents are very huge, and if you were to give, like, some of the documents are even, like, I don't know, 40 50 pages long, and if you were to give like 20 documents of that, and it's already exhausted, the model is exhausted. So our core so our core idea, or maybe the goal of this, is to that the agent or the human being would only probably read 30 to 40 documents at a given time for a given thing. Maybe it's a search or whatever, and then you just need to identify what are those right 40 documents among the 100K documents. And we don't do it by reading the 100K documents. We read it, we go by building the agent that thinks like a person who search things. Like, we'll try to understand the personality of that specific person, the user, right now as well, so we know how our agent should be. Because it's a 50-50 problem. 50% of the problem is that you solve semantics, you solve images, you solve this thing, and everything is like document processing, and that's done. And then the rest is the agent. How would an agent think? Like it needs to use a lot of domain intuition. Like it needs to be in the shoes of a person who is like some sort of scientist or some sort of researcher, and try to know, this is what it will actually need, and this is how the search should perform, and it's going to be on the system prompts for sure. But in overall, that's what I really want, is to understand the personality of this specific person who's going to perform the search and build the system. So it's like a 50-50 problem. You can have best systems with like very good metadata, very good summaries created, very good hierarchy of trees of documents, very good whatnot. And if your agent is shit, like it's basically, I'm sorry, but it'll probably I wouldn't say shit, but if your agent is not up to the mark, if it doesn't work, it both needs to gel and work together. And the agent should also think like a person who's working, and search up. And that's one of the reasons I'm not in this video gonna prompt each specific thing, for this do this, for this do this, for this do this. I don't want to do that. All of this stuff are already trained for the models. The models are already trained on this. So what I want to do is to spike that domain intuition from the models and try to be as general as possible, because that's the end of the day, that's what you want. You want a AI system that's generalized, that bees in the shoes, look into the shoes of the person, of the user or the searcher, and then you try to come up with a search approach, or a search word, whatever the search approach would be necessary. Make it very dynamic depending on the situation. If you were to prompt it and give a few short prompts on that, it's basically gonna sleep on it. Like, let's say the agent would probably sleep on it. So I want to make it as generalized as possible, and also have a good and if you see it in a very normal sense, just two aspects, right? You build the agent, and you build the build the quadrant, and just build the document processing system. That's it. And as long as we understand how a person searches and how it sort of works, we can really tune it and make it as useful. So hopefully that clarifies a lot of things. Let's go ahead, and more than this, I want to understand the personality of the person. I usually understand the personality when I directly ask questions to the person. For example, if I'm working on a bank, and if one guy is going to perform a search, or maybe like get a ballpark on the users, if let's say person A, person B, person 3. I'll have calls with them, try to understand their personality, try to map how would they search and what are their current traditional methods are, what the approaches they use, and try to, and of course use Claude, GPT, just pass in some of the conversations, of course, remove all the personal info or whatever the name and stuff, and just pass it, and then try to get an idea, solid idea on what this guy is actually trying to do. Like, what is like, try to map his brain, because it's not just agents, but it's also like domain specific sort of thing. Like, you need to be able to spike that intuition from the model. So I need to understand what these guys are going through. Sorry for the rant. I guess we'll try to go ahead and try to understand the what do you call, understand about this guy. So I want to know more about the actual user system, the personality. mm, um yeah, and basically I would say basically their brains. Yeah, like, let's see what Claude gives us. I can just be dumb and random here. Hopefully Claude should split that some split some gold. Yeah. Okay, so we just go through this. Stinkers. Yeah, so this is beautiful, I would say. These people who are trained to disrupt anything without data backing it, the entire career is about proving the things work, documenting, and that's one of the reasons why sources are super important, on not just sources, but also being able to. I have an idea of doing it probably, like, whatever query runs, we should be able to show the images, the exact sources, and just give them as much as evidence in a very in a better user experience. You don't want to, just throw a lot of evidence. I'm just thinking of building a very good system that can actually, on the sidebar, it's a UX, to be honest, but then try to have like a better source system, and when they click on it, so you should see the PDFs, or something like that, where they can, skim through, instead of clicking multiple PDFs and seeing multiple sections. They probably can, just scroll through the UI or whatever, check the images, the PDFs, whatever, or the sources for that specific conclusion or whatever. So sources has to be very main. So I can see that over here. And they have deep domain expertise. Senior engineers, Meridian has probably 15 to 20 years worked on those. In yeah. Yeah, some kid with a computer is going to help me find things I've been working with for 20 years. Yeah, this isn't arrogance, it's the expertise. They've seen solutions come and go. Yeah, that's true. They've been buried by IT projects that promised the moon and delivered frustration. Yeah, what this means for you: don't oversell, under promise, position yourself as a building a tool for them, not replacing the expertise. Magic phrase: this helps you find things faster. You can do, and so you can do the analysis. Very true, very true. They're precision oriented, sometimes to a fault. Engineering culture rewards exact specifications, correct terminology, no hand waving. When the user asks what trust chambers with a system, they mean trust chamber specifically, not injector, not nozzle. Okay, see, I'm just trying to get a sense of, just try to understand, just getting to the brains of it. Like, trust chamber specifically, bipropellants specifically, not monopropel, not solid, above 2000 psi specifically, not high pressure. What this means: precision in search results matters enormously. A system that returns vaguely related documents will be dismissed as useless. Okay, so you've seen a lot of RAG where you put in something, and if it doesn't find the information, probably assume things and up and just give it back to the users. Assuming things, like, assumptions here would actually, I think, mostly fail, because the actual users, we're not going to look into any use cases. I think a real user would actually describe as in much as, like he'll be probably very accurate in describing things, and he expects the system to not like vaguely give answers or vaguely assume, okay, this is what he would have meant because I didn't find this information. That cannot be there. So that's one of the points that I can derive from it. Fake positives are almost bad as negative figures. Okay, so it needs to be highly accurate, and assumptions doesn't work here. If there is assumptions, the model cannot assume things. It probably needs to ask it as a question, and they're ready to answer. And once with that answer, it needs to go back. And if that's if this system wouldn't be a consumer app where you just say you put in something and without sort of disturbing the user, where the system goes ahead like GPT deep research and stuff. If you see it, it'll probably ask you like two questions, and you can just type it and do the deep research. But stuff like this, these guys want the questions back. I think I can feel it that they probably are ready to answer a lot of questions because they want it to give accurate results, which in turn is going to save hours of time. So we will build it in a way where assumptions will be relatively zero and relatively give you like assumption will be relatively zero, meaning like it would probably ask it probably stop in the middle and sort of ask questions to the user and then come back or whatever. Okay, so the time start with an interrupt driven, a typical day for an engineer Meridian. Okay, so understanding a day. So how does a day really look like? Working on 2-3 projects simultaneously, getting pulled into meetings, answering questions from junior engineers, dealing with client requests, actually doing technical work. There's a lot. When they need historical data, they need it now, not after a 4-hour active. Okay, Achal type. True. What this means for you, speed matters. Your 5-second requirement is real. And okay, was there a 5-second requirement? Okay, response time under 5 seconds for typical code. No, this is not gonna work, to be honest. Like, if you want to do like a 5-second, like how could you do even like a for example, let's say, so I just noticed this 5-second thing. I'll probably go back and say, no, in 5 seconds you can't do anything, because like what can you search on for 5 seconds? If you want to do something accurate, the agent needs to spend time. For example, let's say you're searching it for like, I don't know, 1 hour. Not just searching. If it's like a basic search, okay, where does this documents okay, where are this X and Y documents or something, or where is this LOX document or something, then we could probably try to do index some documents and like, give them the path. Okay, this is where the documents are. That's less than 5 seconds acceptable. But if they want something complex, like above we saw, um, it was something on the 2000 psi, something like that. Okay, this one. What trust chambers failures have we seen by particular system above? So it basically needs to clarify any assumptions, to be able to search this technical jargons across documents, and also just think about, guys, if you have 10,000 documents, like this specific PSI word would probably be in all of the documents. Definitely will be in 1,000 documents, but it needs to be like it can't read 1,000 documents and see what's relevant, right? So what it does need to do is that, I'm not saying that it wouldn't read 1,000 documents. If it needs to, if it's like a sub agent that needs to gather requirements, it doesn't necessarily need to read the entire thing, perform RAG inside the document itself and get the summary, pass it to a new sub agent or whatever. But essentially what I'm trying to say is that if it's a basic search, 5 seconds is acceptable. But some of the stuff takes minutes, guys. Like, for example, I've built deep research for like like banks and stuff. I understand the workflow. It takes minutes to come back and give you an answer. So I'll probably go them and just push back on saying, I don't know what do you mean by 5 seconds. If you want to automate this, it will probably not be 5 seconds. It'll probably be in minutes. It'll probably be worth it because at the end of the day you're saving a lot of hours. So that'll be worth it, sort of thing. Um, oh, cool. Yeah, I just thought I should mention it. Okay. Okay, two user personas you'll encounter. Okay, first is Sandra, nice, 52. 25 years of Meridian. Was there half? Okay, was there half of the documents? Okay, probably like in tens of like nearly 4 digits of docs, I think. Knows your bodies are buried. Docs failing mutation approach. The time I'm worried about knowledge transfer. Has a mental map of watch. I think okay. Okay, her relationship with technology, uses what works, ignores what doesn't, has seen many revolutionary tools come and go. Yes, comfortable with command lines, old system, of course. Yeah, skippable way. She wants find me the thing I vaguely remember exists, validation that her mental model is correct, a way to transfer her knowledge to junior staff, not look stupid in front of young college. That's true. How she'll judge your system. Okay, so this is where we're getting at the part of how the system we are going to build would probably be judged And exactly, we're not going to have a lot of benchmark. We're not going to benchmark this model and benchmarks, or do like an automated benchmark, but we'll generate test use cases, and we'll extensively test out whether it's pulling the right docs and etc. We'll definitely do it at the end. um so yeah, very important. She'll search for something she knows exists, of course, for sure. If it doesn't find it, she's done forever. If it does find it, she'll progressively hard code it. Trust is built slowly, not instantly. That's also one of the ways when we roll out these products to companies, we won't do like a company-wide rollout. Usually it's a very small testing teams that gives us feedback, and we don't like for example, even though we're working with like 10,000 documents, or maybe even building 485, we only work with a few documents. We only work with like, first of all, we get a chance to look into sample documents, which we'll go through in a little bit, and then we'll actually uh you know build it for a few documents, like maybe build it for 1,000 documents. And the documents, the reason why we can do for 1,000 is that that puts us in a position to see the documents, the type of documents we're dealing with, what are the intricate parts, what are the nuances, so then we can actually know a gist or a summary of what would the next 20,000 or 30,000 documents be. So because of that, what we literally do is that we go back to the users, sort of have the conversation, and yeah, literally, work with 1,000 documents, and sort of uh, have a lot of back and forth, and sort of try to figure out why the system is going wrong, why it doesn't, and how you should build it, and etc. So initially, what I'm trying to say is that you don't initially push out the rollout for like thousands of documents. It'll only literally be for like very, very few. I would say like 5 to 10% of what we're talking about. Let's say if they were like, we need for like 100,000 documents, we'll probably work with minimum 5,000 first, and then work with the domain experts to um, understand going about building the system and gathering more information. And then once we have a solid understanding, then we go ahead and build like strong foundation, strong systems, and etc. So I can literally see, so she'll be one of the early users, I would say. I'll probably take her up, and I'll probably get a bunch of users, maybe like, work with one junior, one senior, and a couple of other people to be able to dynamically and diversely test the system. And if a system fails initially, it's totally okay. The thing is that you want to find where the issue is, and then go back and fix it. You should be able to trace things and have a mental model, and which means that you need to, like, one person should build the entire search. The person should basically architect the entire thing, have like a mind map of what is happening. So then if she were to say this answer was right, but then it gave a different number, then you probably would say, okay, because I probably, this is not in the context, it's probably understanding the images, or it's not pulling the right formula. Why is it not pulling the right formula? Let's test it 3 4 times, and really basically take a very, very super time consuming manual approach to see, okay, these are the 4 agents, it ran it, none of them found the right answer. Why didn't, why, what was missing over there? Is it the context, it is the prompt, or is it the tools, or what is it in that um, um uh, what is it of that natural ability of the agent for it to be able to search or find that information? You can't go ahead and, you don't want to go ahead and say, you find an issue, you go back to the agent and do like a hard prompt for this query, you might have to do this, or this query you might have to do this. It'll not work. You're probably going to have, at the end of the day, hundreds of people using it. You can't mind map the personalities of the search system to be able to, stick to a single approach, or a single recall, not a single approach, but a single uh, um, like a single way of using. So that can't work. It has to be dynamic, which means that I need to dynamically fix the issue. That's the hard part here. We'll probably face some of them here, but this person is nice. I'll probably generate a lot of queries based with the, based on her. So we'll get a chance, assuming that, we're working with Sandra, and Sandra is giving some questions. And what are the win? Yeah. So these are the win for happy times. And person 2, the junior engineer, 28. Okay, very relatively very not a junior, not an intern, sort of like, but junior. Done really good, decent work in 3 years, and I think still a lot of complexity has to be solved over here. And smart, technical, capable, yeah, overwhelmed by Asher, doesn't even know what exists. That's true. Trying to prove himself on the project. Here, I think, like, if you were to ask a question, and uh, okay, we'll come back to the later. I don't wanna. I don't want to waste some time. So his relationship with technology, relation native, of course, he probably have subscription to ChatGPT, Google. So he's very good at searching stuff. And he's also, I wouldn't say searching stuff, he'll probably expect, yeah. So the expectation part will be he'll probably expect more from the system. He'll expect the system to be more proactive. Like a question from this, for example, if this we saw something on the PSI, I think. Let me get that PSI back. Something on the 2000. Okay. So what trust chambers failures have we seen in popular systems operating above PSI 2000 PSI? He'll probably, you know, he'll probably like he'll probably be even more. For an example, this is a very simple question, but still he'll probably leave PSI, or he'll probably mention 200 instead of 2000, or he'll be like, by proper something, he'll type something wrong for this by proper by propelling system or something like that, or just dump in some random stuff or something that's not inaccurate, but then something that's not really enough, where the system has to be proactive enough to figure out what he is trying to say. If there's assumption, of course, clarify it and then come back and sort of search it. So that the high expectations will definitely be there. And also we'll actually read documentation, unlike Sandra. Okay, that's okay. More willing to experiment with features. Okay, that's good. What he wants, tell me what I should look, tell me what I should be looking for. Context he doesn't have. Not to ask Sandra the same question twice. Find relevant. Yeah, and I think I've seen this a lot. A lot of the companies that are built with, they also, like, a lot of the juniors ask so many questions for them, and they just need to dump the documents and give something for the juniors, where the juniors can just prompt and ask the question, and just because these are very basic stuff that these guys with like 20 years experience know. The juniors are, they're very early for, right? Like they have no knowledge on, like they don't have that knowledge inside the company, which is like the company level knowledge. This sort of solves it for them as well. How will nudge system, does it help him look competent? Yeah, that's okay. I'm not sure how this is true for this scenario, but it's okay. Can we find things without bothering the senior stuff? True. Does it help him learn the domain? True. How to how do we know him? Google good results making good projecting related documents. You might, okay, yeah, this is fine. So emotional undercurrents. Okay, we'll just see fear. What if we miss something again? The mass feeling models. So this is very important. Let's go through this. I guess you can just go through this. Yeah, so this is, I think it's exaggerating the system or putting a lot of weight on the system, but it's just trying to, it's just, of course, like people are gonna die because of the search system, and the job of the guys is to verify stuff, but that's basically putting a lot of weight on how much accurate this has to be, more than money, more than what are the context. Like this needs to be extremely accurate. Like there's no level of assumptions. I can feel that over here. And this is of course like a lot of weight, but you sort of get an idea on how what do you call serious the stuff we are working with. So yeah, Miss Philip. And this is yeah, which means that we also need to have a lot of confidence scores as well. We need to show the users. I can see. So I guess we should have some sort of confidence score as well. I'm just gonna know. I think I missed to note a lot of stuff. So I'll just say confidence score. Confidence score as well. Very important. Other stuff I just have on my mind. We can just go through them. Just noting this down. You should give like a confidence score on more than 80%, more than 90%. If it's less, depending on the sources, we'll try to figure out how we can figure out in a way that makes sense for a confidence score to work. To be able to accurately portray whether the information is right or wrong, or maybe even a very less confidence. So we'll probably show it in the UI. So that's one part. I know there is the frustration. I know there is somewhere the current photos. Imagine you've seen a relevant report. We spend a half day not finding it. Give up and recreate analysis. The step in your solving. We need demo system. Watch the faces. Find it something in 5 seconds. Of course, not 5 seconds again. Probably in minutes. But yeah, of course, like peanuts of time. Um, and this is a frustration as well. And this is a very good demo point as well. Whenever I do a demo, or maybe even like, let's say not a demo, but let's say let's say, eh, like we show the system for them initially, or maybe, or in some parts we just do a very small demo for them inside the company. I mean, this is of course after we start working on this. I'll probably always prioritize to demo that would actually you know it's something like this, like they have a core frustration, something that's super complex, and let the system do it in a few minutes. That's very simple, but of course internally it puts us in a spot to solve a lot of other technical challenges, and also to form a huge level, very good amount of understanding. But this is what I'll probably solve for. Like, that's the thinking pattern. I want to not similar queries, not simple queries, but if you were to solve this, simple queries are nothing. Like, they can backtrack it, and they can, those are nothing. If you were to solve something that would take 4 hours in a minute, and accurately to be able to do it, and mention confidence, etc., that's seems to be a good system. What it could be, a finance, it could be anything. It seems to be a very good system. Oh, so the anxiety, the old guard is retiring, Sandra and engineers are walking away. Mental index, junior uh, junior engineers won't know what question to ask. Institutional knowledge evaporates. The system is partly observation. How they'll use the system? Definitely, when you open up search, subsequent question starts big one. Yeah, so exactly, I think maybe this is talking about I think it's talking about the junior engineer, but I don't know. So go to under the constraints, find something adjacent, okay, and follow references, skim the documents, and then pull back. This is what we're gonna say, the realistic pattern, right? They're gonna search for some, so we get a chance of what they're gonna do, and etc. This system needs to support iterative refinement approach. Of course, it's an agent, so it should be able to do it. The trust equation for engineers, accuracy into transparency is about, oh god, effort into past disappointments. Wow, this is quite cool. Um, yeah, I should note this down. Probably I'll miss it. I'm not gonna. I mean, this is just useful, but I just keep it there. Accuracy. Does it find the right things? Can I see why it returned these results? Effort. How hard is, yeah, and passive. Yeah, of course. Yeah. So questions to ask in interviews, of course, and this is what I can't do in this video, is that if I get a chance to ask sort of these questions to like the real guys who are really working on. I reached out to a few folks on LinkedIn, but they gave me slots for the coming week and coming month, like February 12th or February 9th. Have a conversation with like two guys, retired people from NASA, and also people who are currently working in NASA as well. But I can't wait till then. Just probably I will just miss just probably lose motivation or whatever, or miss the need of doing something like this. I thought I should do it as app, and maybe I'll probably follow up, and if they were to give back a different reply, or give us, or fundamentally change the approach of the system, we'll come back and refer it and change the system. That'll be good as well. Cool. So, walk me through the last time you had find historical data. Exactly. What do you do when you find something? How do you know when you searched enough? What makes you trust a new system? What's the worst experience you have with the current? Yeah, these are like gold, guys. Like each answer for each of this question, I'm sure. Even the sixth one, so all six, these are like gold questions. If you were to, like, the engineers gives you, like, they spit gold. So those stuff are very hard for you to, you can't just assume things because you're not in the domain, right? Even you, no matter how many months you spend reading stuff, the answer is way more accurate than what you really could ask GPT or Claude, because that's very different. And enough of those, and some of the times you'll come up with questions or maybe the answers as what do you call, it's probably the same among users, or maybe it's very different, and you try to understand why it's different from the users, and you try to understand, maybe it's like a junior senior sort of thing, or maybe it's like they really work in very different departments, and their departments have very different goals, and you want to solve it for very different goals. If then, what are you going to work on initially, then we'll dissect this for one single department, if that makes sense, and etc. sort of thing. So these will give you goal, but we'll assume things, that what do you want to, of course, like, we're not going to get a lot of answers. What I can do right now is that I do not have, or I'll like be in the shoes of Sandra and accurately answer this question. Oh, my typing is so bad. Okay, and just we'll assume Sandra gives us a reply, and it'll mostly be something like this. So I thought we should definitely give it a try. It's better than not having the conversation at least. So uh, okay, I think it's giving some sort of transcript sort of thing. Oh shit. Okay, I think this is a nightmare. We have to go through the transcripts. Okay, I think it's better. It's fine. Let's go through it. Mm, okay, so this seems to be quite a good perspective, and I hope you got a chance to go through it. You can see the actual pain with them, like um, and you can also see a lot of naming structure of documents are different, and you can see over here she found one document and then it referenced another document, CMARFA, but the document is named like this, like you can't, and but it was referenced in a different document, but then you can't literally search for a name of the file and you can't pull that. And that's where semantic search anyway helps. So I think like we don't need to reinvent the problem. We don't need to, we're not doing traditional search. So we'll probably solve, like it'll be all of this stuff, like most of the stuff will be automatically solved, but I'm still trying to, understand if we were to see a scenario where no information does make sense in the original documents, but it's probably linked to another document, you should be able to, it will be, that's why we use semantic search. So yeah, that's good. Problem solved then. So what do you, I think I want to come back to this later once we have, this is when I built this is when I'll probably build the agent, right? So I'll look at this stuff later, but I'm just thinking whether this will help us in document storing, like, generating metadata or creating some fundamental ground level work that would be useful for building agents. Um, if it's important, but okay, what do you want to do when I can't find it? I document, what, I think this problem should be easily solved. How do you know when you searched enough? Honestly, I don't. That's what keeps me up at night. I have gut sense. So. Yeah, the problem is that you don't know what you don't know. Yeah, unknown unknowns. The failure mode we missed last quarter. Hmm. Yeah, this is a good point to address, to be honest. Yeah. And depending on the search, I mean, of course, it's a search system. They have to still, they're going to use the AI search to search it, but I think it can pull this as well. And I think it should also I think there should be some proactive aspect to it where the agent should, just not bluntly come up with three, but you should go that extra mile and try to also see if there's any contradictions. And you can't hard code to the agent saying, if there are contradictions to it, and it'll probably do contradiction check for each and everything. But there should be some way that I can, depending on the search term, try to check for example, if for this specific scenario, where they were searching onto some contract or something, I think, then the agent should have a chance to check for contradictions. And that's part of its training. We can spike it up. I think we can spike up the domain tuition, but let's see. Um, um, yeah, we'll find a way, but I think you should be proactive. So when you ask, how do you know when you've searched enough? I guess the honest answer is I don't know. Yeah, that's very true. But yeah, sometimes the entire answer is quite scary for me, to be honest. What do you, what would you, what would make you trust a new search system? Okay, this is good. You want to realize I need to test it again, things I already know. Before I trust it, things I don't know. If I don't know, I need to see if I know exists. Of course. What's Yeah, so this is basically yeah, this that's not very accurate enough. NLP search is mainly used for like searching stuff. We just skip that. Yeah, not a strong point. Third, and that's what you're asking Claude, right? Like you'll make up some non-strong points as well, which is okay. You got some of the strong ones. Third, and I know this one better. I need to admit when it doesn't know. Yeah, exactly. So confidence score will probably help here, that if it goes above a threshold, or maybe if it doesn't have, like, again, coming to assumptions, it cannot assume things, and it's a very simple thing, but it just needs to work. Like some other times it might assume some things. Like you have an agent working with 40 documents, and in 40 maybe it didn't assume for 20, but it did assume for like 10 or 20, whatever. Like you can't force the model to not assume for everything, right? So be able to, I don't know, we need to, we'll figure this out somehow. But it's very important point, I think. Yeah, I'll just put it. I'm just making notes. Just I'm not a good, like, I don't have any accurate notes. I don't have documents where I put this. I just randomly have stuff here and there, notes, Notion here and there. So I'm just putting this up. So when I read this, I sort of can recall this conversation. So I'm just gonna put the Claude chat there as well, so I can recall the conversation and I can come back and see. That's the whole goal. And finally, I need not to waste time. I think if I've learned some special query syntax or click through something filters, use it. Yeah, this is also like it's yeah. Yeah, it's like basic stuff. What's the worst experience you've had? This is bad. And also, guys, when I even when I sort of talk to these folks and sort of understand, like, the level of information to storage, because they don't like, because they work with a lot of personal data, right? And not personal data, very sensitive data. like they tend to put it on on-prem servers, they tend to put it on drives, they don't, so they won't push it to cloud, and they're very strict about it. And just because of that, like they miss it. It's just everywhere. It's the That is good companies store it in a very good way. They have policies, but then because this most of the research we work is from 2020, 2025, oh sorry, 2015, 2000, 2010, 2007. It's very different. Some of them have disk drives, some of them have hard drives. Like during 2007 to 2015, they had some migration towards the system, and some stuff is lost among them. Like this is not something useful for us right now. I mean, we are only going to work with the docs that we already have. We're not going to create anything or solve the problems of managing stuff. But this is a real problem. Um, like documents could be duplicated when we are going to process these documents. It could be duplicated, and it could have contradictory information as well. So we should be ready for it as well. And some of them could just have drafts as well. You can't pull it from a draft. It can be a literal draft, and the production one is actually gone. But we need to, in some way, influence the confidence score if it's a draft. I don't know how we're going to do it, but I think when we start off, we'll figure out some things. These are just ideas that I just have on my head, just putting it. We end up having review both are no longer available. Do you know the sounds companies whose entire value proposition institution knowledge? Yeah. If I could magically find any documents, what would you search? Okay, this is the Cooper, I think. Let's say right now specifically, this is documents that I've been looking, half looking for about what for 3 years. Okay, back in 1997, with the sudden combustion stability in small bipolar engines, specifically the introduction between injector geometry and chamber acoustics had off normal mixture ratios. It was theoretical. I think white paper or internal study was not a test report. I remember reading it when I was pretty junior here. I remember thinking it was really good one. I should save this one. Why does it matter now? Because we're running into combustion stability equations on these new small satellite engines. These engines are smaller. The chamber geometrics are weird, and everyone's pushing the mixture of ratios of performance. I keep thinking there was something in the old style as relevant here, but I can't find it. Can't remember who wrote it. Can't remember what was it called. Just remember it existed and it was useful. If your magic system would find that, wow, that's good. That's really useful. Like this stuff is like super useful. Um, Look, I've been doing this for a long time. I have a lot of revision tools. Most and yeah, I just like this finishing coffee. It's so realistic. Most of them are sitting unused on a server somewhere. But I tell you what, the archive is real. It's getting a lot of worse, not better. People who know where things are, we're trying. If you can actually build something helps, yeah, okay, cool. So this is like really gold. Of course, this is not really real information, is something. Now we can do another run through to understand the junior folks requirements that I think quite fair enough if we were able to solve for the guys with the most experience. We just could automatically, I think, could also solve for the junior guys as well, because they're not going to search for stuff that's as complex as this guys. At least what I think, but we can come back to this later because I don't want to spend a lot of time in just going through this random stuff. Cool. I think just check if my audio is working. I didn't get a chance to check it. A lot of time in just okay, just check the audio. It's working. It's okay. Okay. Cool, guys. All right. So this gives us a really good, solid understanding about the space we are working on, the guys we're working with, and their minds, their what like what does the search look like? What does the success look like? So we like we literally, at least I didn't still note it down, but I can do a map of what we've done so far. Is that this is a very complex, accurate space. Confidence matters, no assumptions, very generalized, documents everywhere, technical reports, formulas, whatnot. What you mean could mean very like, and you will have a lot of domain terminologists, and yeah, you have a lot here to solve. Cool, guys. So this is a very good run through. I guess we spent about an hour, sort of trying to understand, what this is, what is the scale we're dealing with, and not the scale, but what are we working, just trying to get into the heads of these guys. But most probably, guys, if when you work with folks at this space, try to have very good conversations, get into stuff this like get into like good conversations. That's what I would recommend. Don't, because those could actually like you'll probably discover so much info on an unplanned sort of a question or unplanned conversations um as well. Like I've seen that work. Like you literally ask a lot of questions and they just randomly spit out goals, and it's like, I mean, of course, like then the system has to work in this way, and it just sort of spikes up. And like this 1 hour we've spent, I'll probably spend 1 to 2 weeks like talking to them and understanding from them, right? Like just having genuine conversations and using GPT Claude, trying to understand what the domain is and what are they dealing with, and just I'm not going to go ahead and memorize all the jargons and stuff. That's not the way I do it. I mean, you just can't, right? Like it doesn't work that way. But overall, I would try my best to do something that's like have an open mind to be able to yeah, just more knowledge and more patterns on how they use the system, what makes sense, and etc. Cool. So this is very good. I'm gonna take a sip of water, and we can, I guess, next we'll actually get started on okay, this is what I think, guys. This is a project very it you have to process documents, you have to have an agent, and it needs to work with edge cases. And Sandra our goal is to make Sandra happy. Okay, we'll just stick with Sandra for now. Okay, and we'll use this conversation here, passing some documents, test use cases. We'll do some extensive testing as well at the end. We'll generate a lot of test cases, but for now, we're gonna work on document processing initially. um Before even that, we are going to look into documents, how documents are, understand, just visually see, like visually see, mind map what these documents are. um and yeah, we can get started. Just a bit, coming back in a few minutes. God. All right, guys. So, yeah, we'll get into doc. So I would say initially we'll just do like an initial plan. We'll start with Cloud Code, right? We'll just make a very high level plan on what we need to solve, and then we'll solve one by one. We'll go through conversations. Even before we start document processing, we'll actually, um, yeah, I would say we'll just get started on a basic repo. So let's create a new project. I think I should get Whisperflow. I switched to a new Mac. And it's easy for me. I can just, I don't want to type. I don't want to spend time talking and typing as well. Done for quiz. Just okay. It's downloading. It's fine. Okay, so let's call it. This is the project name of the project. It's Meridian. Yeah, got it. Okay. Cool, guys. Cool. Should be okay. And yeah, just create a new file called projectinfo.md. So big. Okay. Yeah, so what I'm basically going to do is I'm going to copy and paste this. Um, of course, we'll do all the architecture stuff, whatever is necessary, but for now, we'll just keep it very simple. I'm just going to copy paste this. Just zoom in, I would say. Cool, and we'll open up Cloud Code. Yeah. Be like, this is what we are going to be building. Of course, we're going to have a lot of conversation with Cloud Code, but I just want to, initially solve the document processing part. First, we want to solve the document processing. Yeah, document processing. Yeah, I would say document processing. Yeah, what can I say for document processing? Okay, so what I'll do is that maybe I'm just quite stuck on where I want to start. Usually I have these conversations in Cloud Code itself. Usually that's how it works on. I just, just do all of this stuff in Cloud Code, but we've already done it, so we have a good sense of what we're working on. So what I would say is that this is what we're working on. Cool, guys. So we'll get into document processing. So before that, we need to be able to save this up. So we'll get into document processing, and I'm like, what are we dealing with here? Just be dumb and just ask question to Cloud. Just what are we dealing with here? What is the scale, or what, or how should we support this? How should we support this? How should we support processing of a docs as ton of nuances and nuances, diagrams, formulas, and more. Oh, I mean, we have a good sense of what we're going to deal with, right? I don't think we need to prompt Claude to, we don't need its advice. We know what we're going to deal with. So we'll probably say, actually, create a document. I'll create a document that has info on, because actually I think I'm lost here. No, we'll do one thing. Just keep Claude aside, and yeah, I think we should do. So there's two ways of going about it. First, I would show you the docs we are going to work on and how I pull the docs. I think we'll do that, right? So formulas and I will say make a plan or a progress build plan, how we are going to solve for this documents. Yeah, I would say we will use so we're going to use Docling for document passing and etc. For document passing, I'll come to that. Like, probably you guys have used a lot. Before I used to write a lot of custom pipelines. Now very little amount of custom pipelines, and I use Docling for it. And Docling does give us really good detections on tables, detections, and then we use an VLLM to write like a custom wrapper on top of it to pull in and get the formulas and etc. We'll see that. We need like document passing and quadrant for storage. I think it's simple, yeah. Document passing, sort and quadrant. Yeah, and I think I should pull in some basic info from. Okay, guys, I think what we'll do is we'll copy this. We'll just create a plan. Okay, building. We'll just, this is how I would do it. So what we're trying to do, this is what we're trying to do. What are your thoughts? Complex is this? What should we plan, look out for? Now I'll be like, I want to build this in phases. So maybe document processing first, then what's it, document processing, and then agent, and then deployment. I might miss any information. Fifth shadow and any general thoughts. So what I would do is that general thoughts. So depends on any projects I work with. I want to play dumb over here, because if I were to just bring in all the stuff that I already know and just start typing out and do this, do this, do this, and you probably like there'll be a lot of gap, right? So I just want to play like, be very new to this and sort of try to ask Claude and try to see what it gives me, because I've basically built projects from the suggestions of Claude. Of course, all my research and everything works, we write test cases, validate, but still being able to understand that something like this exists is actually from Claude, which is a huge addition. So Claude would probably give us something simple, some ground. Like I want to have some sort of some documents created for phase one, phase two, phase three. Phase one is probably going to be document scoring, and then document, what do you call, building the document processing, and then it'll have its own sub complex stuff, of course, for sure. That's what we're going to work for. That's what we're going to work next. But yeah, we'll have some sort of thing, ground, sort of document to check through. So here we're going to go through this. Yeah, this is substantial potential problem. Back on thoughts, it's generally challenging. Okay, thank you. Document quality for the multimodal text, stable equations on premise, no cloud being running model, but we're going to use cloud anyway. Failure reports different document is set. Phase one, document processing foundation. Yes, very good. Build OCR. We're not going to use OCR, but still it's okay. We're gonna do for 10K docs, and it'll work for 85K docs as well. But we should be able to have a hold of 10K in order to, and then it's probably like an infra problem from there. Phase two, embedding and retrieval infra setup, quadrant, what, yeah, multi-model understanding and RAG agent response. We'll be like, for now we will use OpenAI embeddings, OpenAI models for VLMs. Let's use Qwen from Together AI, because I don't want to do all the deployment stuff, because there's so much work to be solved in document processing. And then we can, of course, switch up models or whatever. That's not a huge deal. I don't know, that big deal. Let's use Qwen from Together and keep things simple for now. And of course, quadrant, Docker, local. I want to tackle the entire processing in a single phase. Of course, multiple subphases. But overall, I want, yeah, I want to process, overall, I think I have a list of things I want to process, which is, yeah, process. This is document parsing, tables, formulas, pictures of figures, and more. I will share on this later. We can update phase Oh, let's focus on this first. Yeah. Yeah. All right. So yeah, basic document processing, table extraction, figures and diagrams, formulas, nothing. Yeah, this is just good for now. We'll basically change all of this, guys. Like we'll probably change it. Proposed tech stack. No, this we're not gonna use this. We're not gonna do it in this way. But don't worry about the tech stack. We will this, but just the goals document. In a big, because I want to go through the docs and then redefine it and sort of organize this and etc. So yeah, just a minute. I'm just trying to configure this flow because I just don't want to waste time typing a lot of things. Test recording. Okay. This is a test. This is a test. Okay, it's working. Cool. And I also want to make sure the live is going on. I'm going to quickly check that. Like we'll probably change it. And okay, I think the live is okay. Cool. Sorry for that. Cool guys. So all right. So we'll send this stuff and let's go with document processing for now. We will plan this out in a bit. I want to first of all show you the list of documents we're going to work with and then of course come back to it. Yeah, but I want to just save the plan and then just get started with that. So let's see. And basic document processing, tables extractions, show me just yeah. This is okay, just sounds fine. Seems okay. Just the open plan. Basic document ingestion, table extraction, figure out flow, whatever. Okay, cool. So we have a plan. Now we need documents, right? Initially we're gonna work with 10K documents. Now the good thing is that NASA, I want to pull all of these documents from NASA's website itself. So if you see, they have a site here called NTRS. NASA. So basically, this is also available through API. I just ran the code and pulled like 10K docs overnight. What you can do is that you can start search, and I can just show it to you right now. So if I were to go ahead and search for, what was that? I think it was LOX liquid something. Okay, maybe we'll just go with just LOX and type enter. And yeah, liquid nitrogen dilution. If I were to click on this, you can see you have an entire document. You can actually see this document as well. And then this is one document, and you can see the entire document. It's quite huge as well. You have a lot of diagrams and etc. We'll go through each and every one. So you don't need to manually do it. You have I leave the code once the live stream is actually done. So I think I have the code for it. Let me open it and see. Um, it was rocket test. Uh, okay, cool. I think it's over here. Let me see. Yeah, so I think you can see this on my screen. Okay, my second one. Cool. Yeah, if I were to go ahead and open up NTRS, so I have a code. I just wrote just one single line of code, guys. I'm gonna leave this up. They have an API. What I basically did was that I called the API. It does have like a rate limit, 500 requests per 15 minutes. So maximum is 100 results and of course 10,000 records, whatever. But then you'll hit this limit very soon. So don't even check for headers and etc. Just directly make the call. I'll leave this code. I just ran this overnight on an on a VM. So let me see this. Okay, I think I missed the credentials of it. Okay, cool, guys. Cool. So this is my SHS. So I've basically created the VM and I just ran this overnight because I can't afford to like spend like 25, 30 gigs for this. I took about 13 hours or so, I think. Not 13 hours for 10 docs, maybe even less. Not 13. I actually ran them in parallel. Probably like less than, I don't know, probably like 5 to 6 hours, maybe even 7 hours. But let's see. Um, yeah, and you can see list all the PDFs. Oops. Okay, so okay, I can maybe send a different folder. Oh, it's the VM. Let's find out. Alright guys, I guess I was saying just figuring out how to show this to you guys. Cool. So you can see I've pulled in some documents. This is just showing like 2 documents over here, and this is all from NASA. I've just saved everything from them, and the entire count, I think it's 10,414 documents. So we have about 10,414 documents, and we are not gonna spend time on 10,000 documents right now. I have basically pulled in a little bit of documents over here. That is a good, what do you call, a very good um, like randomly pulled in documents that really portrays the like the different parts of the document, like something that really depicts like sort of like a real world scenario where you have like documents with a lot of images, a lot of text, a lot of formulas and etc. I've done that. So I have about 50 documents right now with me right now. But at the end, once we sort of figure this out, create we'll probably process all the 10,000 documents. So I have with them. Initially, we'll work with this few documents right now. So we get a chance to see what we're really working with. And then we probably process this overnight in the VM, and we'll have everything stored in Quadrant. Cool. So you might not need to have 10,000. If you want to have 10,000, you should, leave it for hours. I think it's like 4 to 5 hours. But I would just recommend, if you're starting out, like, just following along or something like that, just work with like a couple of thousand, like thousands of docs. Um, cool. So, okay. Now this, parsing. Let me pull in the right document. Okay, Rebellion Finder. Cool. It's NASA test, and we have a couple of other documents to work on. So guys, I'm going to go through all the documents right now. Most of the documents would actually portray, so we get a chance to see what documents we are dealing with right now. And then once we figure this out, we should be able to finally process this for all 10,000 documents, and then merge, just get the current up and running. So yeah, so we'll start with this. Is a very good mix. I spent a little bit of time curating this just to give you guys a very dynamic sense on the dynamic sense on the documents. So we'll just go and just see them, just see the documents, right? We need to get a feel of what we're trying to work with, like what we're actually working with. So just click on first one and just see this document. Let me just double click on it. Cool. Yeah, and I'll just go through the doc. And this is probably from, I don't know when this is from, but okay, 1967. I think it's 1967. I think so. Maybe, yeah, maybe 1967. It's like a very clean copy, to be honest. A very clean copy. Yeah, so right off the bat, you can see that there's a lot of like intricate pieces over here. Not intricate pieces. For example, if I just scroll down, just see this, like this particular text. Like if you were to pass it, if you were to gently pass it using a basic pass, it'll probably fail. But this is still fine. It's not a formula. It's not much. It's not much of a complex sort of document, so we can get away with it. It's okay. And if I just scroll down, I'm just seeing the nature of the documents. It's text. It's text. You have references, and yeah. So see this. So this is an exact. I mean, this is an actual table, but it's a huge table, to be honest. So um, can I turn this? No, it's fine. I'll just keep it like this. Okay, and see this, like this is an entire table, like really huge, and there's tons of information into it, and you can't just chunk it, right? Like this is one huge problem. This is a figure. You can see the figure that runs also used for a figure 0, figure 7, effect on injection patterns, radical coverage, and you can see the level of like, let me just zoom in, like you can't extract this. Like even if you were to extract, you can't just flatten it and just use it as context. Like it's it's just gonna it'll be so much inaccurate. So I'm just trying to, so for the next 30 minutes, what I would say is that we are going to spend time looking at 30 to 40 documents from the 10,000 documents we downloaded. 30 to 40 documents to get a sense of what we are working on. We visually need to see sort of the visually needs to, like, sorry, we visually not make sure, but then we visually need to understand the sense of documents, the scale, and also the sense of documents we're working on to be able to build it properly. So there is a table, there's another table, there's another, okay, this is also quite huge. So if I have to zoom in, you can see there's so many subtle information, you can't miss it. Like even this particular, you can't chunk it, so very important. So we're going to work with tables, but these are not like basic tables as well. It's not a table, it's basically like a figure. We actually want the model to actually like accurately do this, like accurately map out the table, and probably written a JSON, I suppose written a JSON or even a Markdown, but it need to be able to like accurately represent this table. And table one, same thing. You would have the same experimental data. It looks quite the same as well. And over here you have an image. Of course, and of course you have another two images as well. And you have a graph over here. I don't understand anything from this, but I can understand that this has like this graph would need to have the context of the I won't say it's tables, but it should, like, you can't we should be able to chunk the table but also chunk the above paragraphs or whatnot, the below paragraphs, or at least have some sort of hierarchy of documents to be able to let's say we found this table, right? Like, to be able to find this table, like, we can't search by images, I have to search through text. So what we'll do is I will probably take an image of that, send it to a VLM, get description, and when the user were to ask something, um were to ask something relevant or something like that, we just pull up the image. And also, but we initially do the sorting or the semantic search through text. Of course, we'll have some sort of decent metadata as possible, and then try to figure out and bring this image. But I think, yeah, these are images. Usually what happens is that you have a graph, and then you probably have like text above it, text below it, where you can use it for chunking, because those data would be very, very essential for us to you know to us to grab this table among like tens of thousands of tables. But um yeah, it'll be quite tough, so we'll figure it out. There is no but yeah, there's a ton of this is very document oriented. You can see very, very very different sort of graphs, tables, documents, and images as well. So photo, wagon wheel, and these are stuff that we will actually sort of, like, for example, when the user sees, like, asks a question and sort of we pull up this table, we'll actually show this as an image, so where he can click on it and see as well, and it'll make sense for us as well. So this is one. Let's quickly go through a few documents over here. So this is the second one. um Dual turbo pump liquid hydrogen feed system. Cool. Dual turbo. Okay, so this is also text. This is fine for chunk. Like, this is fine. There's nothing complex over here. We scroll down, looks fine. And of course, this is a table, and we can't directly chunk it, so it has to be a table here. It's a table. And yeah, apart from it's a neat PDF. Oh, so no, it's not. Huge table. One more table, and you have visual representations inside the table. So it's not like like a basic financial table where you have like columns and numbers and you just deal with it. This is totally different. You can see the probably have to turn my head. Oh, so much to see it. And see this, like, this representation of a table is also very different. You can see this sort of grouped lines. I don't know what you call this. I have to like dig more information on that, but I think it's like it's very much grouped, and I think it's very important we capture the nuances and also that particular group as well. That has to be mentioned. We'll figure it out. I think one way of doing it is that you can let the LLM have notes section where you would probably add stuff like this in notes, where you can't accurately represent stuff in a markdown. You probably add it as a note and send both to the LLM. It has the notes, it has the markdown, it has the images. That's more than enough to get an accurate representation of what it's dealing with. um Table this thing. And yeah, see this, like, I would say this is one of not, this is also not complex, guys. Like if you were to say, like VLMs can process this, like even open source models can easily understand it, or at least generate descriptions of it. So this is okay, we can handle this. And also if you just generally see this, right, it has a lot of text. So far we've seen a lot of graphs, a lot of tables. What we need to do is that LLM should be, we should be able to process the text and then the graphs, get an accurate representation, or if it's a table, then we can do markdown. If it's an image, we can do descriptions, and then just save it with along with all the metadata, like, what is it from the summary, or is it from this particular text, and just having a 3n hierarchy of, like, hierarchy represents, let's just assume, let's say we're dealing with this particular text, right? We're dealing with NFS3B development program, and we come across this text. But if we want, we basically, and we assume, and the agent decides to read the entire section. If you were to normally chunk it, you just can't read it. One thing is that you can go above to a certain level, below to a certain level, but you will never be able to accurately identify A, that this is part of this whole section, B, you'll waste a lot of tokens. But I did a lot of like parsing, like very stupidly hard, like code, like literal pipelines to parse it. But this time we're using Docling, and Docling really helps us to, and it works quite decently for like textual information, for example, detecting even hierarchies. So what will be is that it'll probably be under, you will have a heading, and this info would be under a subheading. So I'm not able to find what the subheading is. Maybe there is no subheading, maybe that is the subheading. But at the end of the day, you can let's say you have, okay, summary, right? You basically, the agent comes across this particular dump of text. What it can do is that this will have the metadata of this particular summary. So then it can act, not this, by the way, like I'm not able to select summary, this one, and then it can basically get all of these chunks part of the same thing. So that, which means that you need to have this hierarchy of or maybe like a tree of where the paragraph is and what is this paragraph part of. Is it an entire section, or is that section part of a different section, or is there multiple sections, and etc. And Docling by default, I guess it does a good processing. They have their own models of doing it. And for tables, we are going to use Docling to detect it, but then we're going to use a different VLM, probably like Qwen-3 VL, I think. I used it a couple of days ago to process this stuff, right? So fairly, we know what's going on right now. Okay, you can see the images over here. Some of the times, sometimes, depending on the model might assume both of this to be a single image, or it could dissect or divide this by, this is one image and this being one image. But still, as long as we have like very good, like you can't prevent it, like anything could happen, right? You just work with the edge cases. In case if it were, if the model can figure this out, if it mistakenly assumes the entire thing is an image, it's still okay, because we still have descriptions, and the agent, when the information comes in, it can just focus on the stuff that's needed, and just not spend time on the things that's irrelevant. But I think you should be able to, like, you need to be able, you can easily dissect this to be like two layout images, something like that. You have images and this black and white images and etc. And of course this pumps, this is very useful. You can't, the agents can't, like the VLM can't regenerate an accurate representation of it, but it can understand it and give basic details that can help the agent pull this info. That's more than enough for now. Again, diagrams. Okay, cool. Let's go with something else. So this is text, and yeah, technical report standard. And also, guys, just notice it, right? Just notice patterns in the document. These documents are well labeled most of the time. There's one thing called technical report standard title page. Sometimes it's in the end of the document, or maybe even start of the document. But most of the time you would find something like that, and this has really good metadata. For example, just read the abstract. This basically gives you an information about what the entire document is. If you were to manually do it, you probably need to pass the entire document and get a summary and then store it. And because of that, we can't do it for 10,000 docs. We can't afford for it, and we don't do it. But you probably have this technical standard title page. This page probably end, or the initial level, whatever. At least what I've seen, that most of the time you have something like that, where you can extract this abstract and chunk it to that parent document. So in case you're searching for something, and again, even if that leads to this abstract, you without reading the entire document, you know what this document is mostly talking about. And it has info on when this was created, I think so. So if someone was like, find me on something on 2000, okay, this is 1972, okay, so that's really good. Find something out from 1970s, you can easily, because this metadata is there, right? And you can't use PDFs ground metadata, because PDFs could be scanned on 2012, 2016, and mostly that's the metadata. But the actual report was like, because the actual report is from 1972, so you should be able to like not every time, but then most probably try to depend on something that's already available for us. If you see the pattern, this is available. Just notice the patterns, guys. Try to do pattern matching. Like there's a lot of text, but there's one technical standard title. There's metadata which we can use. So we'll just keep that in mind. Use metadata from standard. We call this standard title page. Okay, guys. So that is nice. That's very good information. So just notice patterns. I would say just notice patterns. Blank page, preceding blank page, and of course this has like you have contents right now, but most of the PDFs you see, you don't have contents, and you can't necessarily like good thing is, I'm just talking as if I'm gonna do a lot of hard work in writing contents, but not necessarily is like Docling is gonna handle it. But I'm just saying that if it has contents, good. And context on content is good. If not, it's okay. You have an abstract, you have an introduction, and okay, and you have documents, text. Everything is text. So basic text, images. We know this, easy. And yeah, stuff like this. Just see this, guys. I guess this is 150 MB or something. When I was downloading it, checked it. I wanted to get like a accurate representation of very diverse sort of data sets that we are working with. So it makes a very good recall. It basically portrays information on actual 10K, how diverse the 10K docs are, right? Not clean. Some are images, some are graphs, some are tables, and yeah, whatnot. I guess this was 150 MB. Okay, it's 5 MB. Okay, whatever. Still, you see a lot of images, right? This is totally, I guess it's a PowerPoint presentation sort of thing. And you have a lot of images. So see this. So this is an image. This is an image. This is a graph. Of course, for us, it's sort of like an image. We treat it as a figure, whether it's a graph, whether it's a, formula. Formula is different, but yeah, we treat this as a figure. A graph could be a figure. And you have these images as well. And yeah, this is the table, but still, just see the amount of context you can't represent this in a markdown, right? Like if you were to think about this, you can't you can, but not this red circle. I don't think so. You can accurately do it in a markdown. So what we do, we can have enhanced notes to it, like, that would portray nuances that a markdown cannot capture. Merging that would give you a good context on the image. Yeah. And then you have this graph, it's an image. And yeah, this it's yeah, it's a PDF with a lot of images. Yeah. And yeah, as long as we support figures, they should easily work. Okay. And the good thing is that, guys, that now let me open this JSON and show you what it has for one of the documents. NASA has okay, this publication date is also available for us. It's good. Not all the documents, I wouldn't say not all the documents. When you work with companies, they don't manage metadata. Somehow NASA were able to, I guess, do a lot of post processing and pull in the publication date and have a lot of good metadata which you can use. I'm going to pull another one. It has authors, it has the abstract. These are gold, guys. Usually what we do, we create stuff using LLMs. What we do is that we process this stuff, pre-process stuff, do like, regex matching, and find this info in the documents. But the documents that we are right now dealing it has very good metadata, but 90% chance you're probably not going to get it when you start working with a real company, because they don't have time for it. And just see this is very old, I think. Okay, 1963, which is more than 50 years. Yeah, just see this national, but you can select this text. The scan is very good, guys. Scan is very good. This is good, and we should be able to handle all of this stuff. Text, and here you go. You have formulas. which is also, we're going to solve formulas as well. What we're going to do is that we'll basically take a picture of this when we detect it's a formula, and Docling is going, we're going to use Docling to detect formulas as well, which is using LaTeX, I think. And then we will detect this particular, what do you call it? We'll detect this formula and then send it to a VLM, get a representation. Just to have more context, what we'll do is that we'll send like 500 chunks up and 500 chunks below sort of the context. So, and then along with that, we'll send this image. So then it has context on what it's dealing with. Okay. And yeah, extremely 1960 paper, but extremely cleaned copied PDF. And you see this formula, which also can be extracted, that it's a formula. There's references, and then you have, yes, tables. Easy, easy, easy. Solve this stuff as long as and graphs. Yes, we can do it. Yeah, I don't even know what this makes, what this is about, but of course we can just use this text and generate descriptions. William might understand it, might not sure. And of course we're using an open source one, so it might not. uh, that's that. And see, we also, now this is the second document. It has an we can see an abstract, we can see the authors, we can see the titles, the extra. Guys, quickly, I want to see whether my voice is being streamed as well. Just a minute. Portray nuances that a Markdown cannot capture. Okay, okay, it's cool. Cool. Yeah, guys, sorry about that. So, oops. Okay, this cool. You have abstract, good. We can use it for metadata, easy. We have tables of contents, very good. Uh, this supposed to, we can just embed it as an image still, as long as it's an image. Like this stuff is quite noisy. You just can't make sense of it because visually you can't really see anything. But still, just a helpful info. You just have to show this image and they'll just figure out whether it's right, what to make of it. Table 2, we have tables. So we've seen tables, we've seen formulas, we've seen images. Mostly that's what we're going to deal with, I think. And you see graphs, scroll up, same thing, we can figure this out as well. And okay, now this is a bit complex now. Okay, and this entire page is an image, guys. Like it's like, I think this is not page, this is actually a design where I think it's a full it's a it's a very wide design, so you can see it. So you can see the cutoff here, and you can see the continuation over here. You can see over here, and yeah, and this okay, that's huge. It's very huge. And oops, and then you also have duplication. You basically, I guess this is the same diagram as this, but you have another figure 14 there. This is very complex, guys. It's super complex. These are fine, but I'm just looking, how could we even handle this? Like, we need to merge images. We just note it down. I'm not sure we'll figure it out. Let's say merge images, graphs, cross pages. I guess this is a very low. I guess this is a very low priority. So we'll just keep it there. Yeah, still okay. Again, I guess documents from 1960s, 70s, 70s, 80s, we can see a lot of the patterns like this. Mostly, guys, what we do is that when we work, we tend to work with the latest documents. Like when we take 15, so let's say we select 5,000 documents, right? The initial POC to work, we'll actually work with very recent documents. Not very recent, meaning it's not like 2025 documents, probably like 2015, 2010, 2000s. But the moment you deal with 1970s, because most of the stuff you're dealing with on the research papers and stuff, mostly they are sort of maybe outdated. I'm not sure, but there's a good chance they are outdated. And and just humans, right? You are probably working with, most of the time you're probably working with a lot of the recent information, so we prioritize this. But I still wanted to capture that and show you that we should be, you see, just see this, like it's so complex. You can never, unless you look at just look it for a few minutes and you go down, come back, go down, come back, try to figure out. You'll never be able to like this takes human effort, guys. So this, we can't expect the LLM to solve it, and we are not gonna we don't want to waste time solving this right now, because there's even more problem with more latest documents to solve. So but still, this is something on low priority. We can come back to this if we want to do it. So again, images very I would say like not the best document. Yeah. Cool. This is the second document. We got abstract. Very good. Yeah, mostly you'll see abstract. I mean, most of the time you'll see it. Text, 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 text. Diagrams, 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 diagrams. Yeah, yeah, yeah. Yeah, nothing huge. Very simple, to be honest. Just something else. Okay, this is PowerPoint. Even easy. Most of the time it's images, so it's easy. This is a very clean document. I think it's from 2025. Okay, 2025. Yeah. Okay, so this is, I wouldn't say complex, but it has a very different layout. Like, like if you were to chunk this page, let's say you're chunking this. No, I think you can still work it out. Yeah, it'll work out. Yeah, you have images. You have images connected to different sections. The thing is, guys, I'm just thinking whether this will be chunked. Like for example, if Docling would, or if the parsing would probably think this as a chunk. Like uh, I'm just thinking, if you were to chunk it, would it like chunk this first, chunk this first, and then chunk this first, and then chunk this first, or would it probably chunk like this, like without any yeah, I don't know the word for it, but um yeah, I don't want to chunk it like this, so we'll figure this out. So this document is brown. Okay, we'll see how we have to spend time on this, but it gives us an accurate representation on how we have to chunk for stuff like this. Where if you were to chunk it, like if you to chunk this horizontally, it'll be wrong. It'll definitely be wrong. So you don't want, like for example, it'll be like the MBB models were built by utilizing from, it'll go like this, like from I think, I hope not. I could be wrong. Let's see. Um, Same document, a lot of graphs, and I like these graphs for some this thing. And you have very intricate pieces as well, and we need to specify. We need to crop some images if we want to for the models. In order, for example, like we as humans, we zoom in and see, right? The models might miss some nuances if it's a very small image, so we might need to zoom in on certain particular images. But let's see if that's needed. But this is okay, and it's a clean PDF, so one image is more than enough, I think. And this is from 1950s, 60s, sure, 1997. Yeah, it's from 1997. It's worse than the 1967 docs. Yeah, yeah, diagrams, figures, and its figures are upside down. You can see it's actually upside down. It shouldn't be a problem for the VLM, so it's okay. You have a lot of graphs, and let me see, a lot of text. How many pages? A lot. And you have handwritten text. Now this is where the problem comes up. We can use OCR to get this chunk, but let's see. Let me open this in preview. And you're also dealing with a lot of handwritten text, right? We should, I think the best is to use a VLM to assume what is going on. VLM, like, just don't get me wrong, if I'm trying to push this to a VLM, like OCR, I don't think it'll be best to work for this. It'll be more accurate to use a VLM. Okay, cool. We have a sense of handwritten notes. We'll make a note. Handwritten notes, still low priority. And yeah, we'll go through some docs. I don't want to spend too much time in this. Same thing, guys. Graphs, 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 graphs. Images, graphs. Images, graphs, images, graphs, images, graphs. Okay, there we go. You got some formulas. Yeah, so you got some diagrams and also formulas. This is a bit tricky. Uh, we can handle this for sure as well. These are images, because we are anyway passing the above 300, 400 chunks. The context is already there for it. And you have some formulas. These are nothing, very simple ones, to be honest. Two diagrams. Let's scroll down. And yeah, diagrams, easily solvable. And yeah, this also has documents, and this has a lot of formulas. So easy, we'll solve this too. Technical notes, scroll down. Appendix. And also guys, just notice this, right? If I go back over here, if I scroll down, I saw something on symbols. Okay, you see the symbols, right? So in a given documents, or mostly, you'll have this symbol called A, H, G. You have symbols and they have text. So these symbols are actually used everywhere in part of any documents. If you were to go down for formulas, or maybe even if you go down to this images, or maybe even text, these symbols are actually used instead of this information. Now, if you were to chunk it directly, just just randomly chunk just get the document, just randomly chunk it, it'll be a nightmare. It'll be it'll be very wrong, and very wrong in a very wrong way, like very bad way as well. Because this is the essential context. If you were to miss the symbols and just chunk it, you'll get it mostly wrong. So, and if you were to see symbols onto a different document, I guess this document did also have this part called symbols. So I'm just trying to give you an info, try to pattern match things, right? Just see patterns in documents. Just try to use everything in your advantage in order to, do the chunking, or do like like to get the system up and running. Like, because these are the stuff that these guys don't mention. Like, they won't just spoon feed you this stuff. You need to look into this. And you can see symbols over here as well, and this is used across documents, and this is the standard as well. Like, they use appendix, they use symbols, and this is a good thing. So what we can do is that in our VLLM, in our processing of the documents, what we can try to do is that we can first, okay, so I'll just note this down. First we try to understand. So this is okay. So cool, I'll note this down. So we first try to understand the technical paper which has metadata, try to pull as many information from it as possible, and then we also try to understand the symbols, where we also try to grab all the symbols from a page. There's a way to do it. I'll tell you when we do it, but there's we pull in all the symbols from the document. Is that right? Yeah, we pull in all the symbols from the documents and pass that symbols to among all the contexts. So whenever we send an image to a VLM, we get the entire symbol section and send it to a VLM. If it's an image, we send it. So any external API call that we use to generate a summary or something like that, we always use the symbols, and we also store the symbols as part of a metadata to the document. So whenever we work with documents, we get access to the symbols as well, which then makes more sense, because R, and I don't know what you call this, but this could mean very different in very different documents. So symbols is very important, and this is a huge advantage for us. Usually you don't find this stuff in a lot of documents. So yes. Cool. Yeah, paste it. Good. And we have this information over there. And of course, it's a mess. I'm just verbally trying to put that up, so I don't need to type this out. And yeah, that's good thing. We have symbols, we have metadata as well from abstract. And yeah, cool. And also, even if you see abstract, right? Mostly the abstract is what I can see is that the abstract, it doesn't have any spaces. So we don't need to use any VLM to get an abstract. You can just search for abstract and then just split it on a new line and you'll get the entire abstract. You don't need to use any VLM for it. I don't think so for now. Scroll, same thing, images, PDFs, whatnot, and scroll down. Has a lot of tables, and of course we have the report documentation page, which we'll try to use it. Same thing. And yeah, guys, yeah. So this is, I've spent a lot of, like, enormous amount of time background, a couple of days, trying to look into the 10,000 documents and just try to get an accurate representation of each diversified document. So I can confidently tell that if I were to solve all of these documents, we have new ones, old ones, mid ones, tables, images, graphs, formulas. Some stuff have abstract, some stuff do not have metadata, some stuff do have good metadata, some of them have very bad images, some of them have is from 1960s, and some of them are PDFs, some of them are not, some of them are PDFs, everything is a PDF, some of them are PowerPoint presentations, and some of them are image dense, some of them are, and you haven't, and this such a whole, what do you call it? It's so big. Like, when I mean big, I mean, like, it's very diverse, that if you were to solve for all of this, mostly you'll get the rest of the 10K, 20K, whatever documents, because you can't necessarily look into 10,000 documents. What we can do is that you can look into 100. Like you can, when I mean you look into 100, I mean you click on 100 documents and see patterns across documents and make notes and try to understand what is that the document, what is that the document is, like what's the domain of the document, what's the generality of the document, what are the patterns do the document share, like what is it, like because each domain has have their own way of working. And aerospace, you would do processing and post processing in a very different way. For financial, it's very different. They work with a lot of excels, they work with a lot of numbers, easy stuff, like you have tables labeled, you have everything in numbers and stuff. You don't have graphs like this or black and white graphs, and they mostly work with very recent information as well. Same thing for pharma, you have images as well. You'll have a lot of graphs, but their graphs are very much good, not like the rocket science one from 1960s. Um, cool guys. So I think I'm sorry if I'm taking a lot of time spending like a few hours on this. I think these are the stuff that when we build, like I don't want to do it as a YouTube tutorial sort of thing. I'm gonna share the repo and have this video going on still if you want to look into some parts of the video. I'm sure you're not gonna look into an entire live stream, but this is just to get it out there that to build systems or stuff at scale. I sort of think you need to do it in this way. You need to spend time. Like there's no point just jumping into code right away. And what do you write? Like just from the AI say, hey, just go ahead and what do you call it? Do you prompt the AI say, go ahead and write document parsing for rocket science documents? You don't do it. Like that's not and that's not how it works, at least to the stuff that I've done. So yeah, so we have an accurate representation of what we are going to work on. Everything sort of makes sense to me, and yeah, we'll just jump in. We're going to work with this initial set, and I'm telling you, if you were to solve for this accurately, which is itself a nightmare for a bit, until we figure things out. But once you do it, it'll actually work for a lot of documents, and you're good to go. um cool. I'm gonna quickly get some water, and I'm gonna quickly get some food or something like that, and I'll come back and we'll actually work on yeah, we'll actually work on yeah, we'll just get started. We have to start somewhere. There's no perfect way of starting it. I think it's good if we start on document processing. We just do all the post processing stuff and store coordinate, and once we do that, next we can work on the agents and stuff. And yeah, see you in a bit. So okay, so I think this is what we're gonna work next. Basic document processing, table extraction, formula extraction, picture document processing, and hierarchical processing. So this is what we're gonna work on next. Make sure to update your plan or build process. Not sure how is accessing the file. Okay, now and I think it should. So this is just a just a boiler template, guys. Like, usually, what happens is that I'll definitely have a lot. Let me review this. Okay, we have like initial document with a lot of information, conversations, and whatnot, and then we select phases by phases and work on. But this is just a good starting point for us to get, because this is quite important, right? You can just start off with document processing, which is the most important part. Once you figure out things, then you can try to at least for now, at least at this live stream, these are the important parts to work on, nothing else, not the UI, not the anything. The document processing is the important part, and we'll work on this. So we're going to use Docling to do document processing, right? So I'm just gonna, okay, so the GitHub is there. They have models as well, and this is through IBM, I think. Docling is through IBM. Yeah, I think so. Yeah, all the contributors. Yeah, from IBM. Cool. Um, cool. And you can see passes multiple formats: PDF, docs, PPTX, and it's not really perfect. And we're gonna write wrappers around it as well. But it gives us very good extraction. It also gives us very good decent amount of extraction. That's more than enough. From there we can actually use custom passes to build around. So that's not an issue. So overall, in a face value, you can see it has a lot of, it can so what we want is that we just want to support PDF, PPTX, docs, and most of the time these docs are PDF, and I'm right now working with PDF. Doesn't matter, this is more than enough. They have a lot of VLMs. It's called Granite, but it's not really great. We'll use Qwen for it, but is that if you want to run it on a PC, you have a very small hardware and accuracy doesn't matter, you can actually go with Granite. It's totally okay with it. And yeah, it's pretty good. I don't want to waste much time. We can explore the docs using Claude itself, because we're gonna work on all of this stuff, and we'll see whether Docling sort of supports this. So I usually create something called, I if there's docs, I use if there's docs, search the web. That's better. But I just clone the whole repo so it can get into the codes, and um, yeah, you can just literally get into the code and check if there's any issues, or really get a good sense of the code, because docs wouldn't portray most of the most like most of if you want to write custom parsers, like you want to do a lot of like digging inside the docs. So I just sort of clone it. The docs, git clone. What the hell is that noise? Cool. I think let it download. So yeah. take a bit. I think it's about 200 MB or something. 200. Just export this. Usually this has been a lot of time saver for me, because before I used to write custom parsers, which has which used to be very not very not 100% accurate, but not a lot, not really accurate. You don't wait. I'm getting some sounds. Very 100. Okay. Cool. Yeah, it's not because what I used to do before is to have VLMs detect tables, and then it's not accurate and etc. But their layout detection model is very good. You don't like you don't need to accurately, how can I say, you don't need an accurate representation, or you don't need to accurately extract the table. You just, if you just have the table, the image of a table, that's more than enough. Docling helps that. That's more than enough. I've seen this way work for me. I mean, people could, necessarily could depend totally on Docling. It's okay, but not for me. I use it for chunking. I use it for table extraction, and then I from there use other VLMs. You can write custom wrappers to it. Not an issue. I have some code for it. I'm gonna copy and paste that, and you should be able to do it. I think good. So I'll probably be like analyze Dockling's code and try to see if Dockling supports all of the above focused components. I mean, yes, but for the sake of I want Claude to just access the docs for a bit and have a basic understanding about the what do you call it? The features Dockling provides, and also the code and how to use and etc. Because it's easy for us to then sort of prompt it and get it done. So yes, I think I'll also make a copy of the folder. So we'll copy the entire thing and we'll call them sample docs, and we'll paste them to here. Okay, we'll paste. And you have metadata along with all the PDFs, which is mostly an accurate representation of the TNK files we're working with. So yeah, it uses a sub agent to explore this, let it do the job and come up with some answers. And also, guys, as I move on, I'll just think and just type it on and naturally start doing it. Again, you can sort of observe what's going on, because I don't have that much energy to keep talking for the next 4 5 hours. So I'll just show it to you whenever there's something important. I'll just bring it on and explain. But then from here onwards, I'll probably like prompt it and sort of build it out. Okay, I think it's done. Cool. Yeah, the stuff we already know. The pipeline test, right? Yeah, so I think we'll solve document parsing. We'll just parse the document first, and see how crap it is, and see we'll just take it from there. So general, so we'll be like, um, let's now work on document parsing, right? I think that's the first thing. Load the PDF natively, just embed it and just save it. I would say for now, save it to a JSON. We'll work on quadrant a bit later. So this way we basically could see what's like. I don't want to go through quadrant and query all the vectors and etc. Embedding, not at all important right now. Super simple. Get the JSON, see what it's giving out, get an accurate view on what it's spitting out, document it's spitting out, and then take it from there. And of course, we know that it supports all of this. So as we move on, we can just sort of add this and solve it. I'm not sure why it's doing so much research, but it's quite simple. You just import the standard, the PDF, and then you just chunk it. It's simple, but it's still, I guess, it's just trying to look into how it should deal with formulas and etc. It's okay anyway. It's okay. Like during this wait times, we can actually explore domain-specific terminologies, but um, I think we'll just confuse. We'll just finish this up, and we can start on that next. It's quite a simple thing, but it's writing an implementation plan. It's okay. I guess with the new update, it automatically switches to plan mode. I think usually it doesn't before, but it's still okay. Doesn't matter. Um, yeah, I have API keys. We'll take care of we'll load the models later, all the stuff and run pod or whatever. For now, we'll just use to get the API and yeah, open APIs and yeah, for now it should be okay. Yeah. Oops. Yeah. Have sample PDFs. Yes, I do have them. Which is but I usually manually approve everything. I don't want to take the risk if you write something and yeah. Docling, Tickdown, transformers. The versions I think I can use the latest versions. We'll just we'll like use all. Yeah, that should be okay. I think we might hit with packages issues, but it's okay. Not a big deal. Loading with okay, and create a .env file. Oops. I don't think Need to use this. Well, we can remove this later if we want to. So we just keep it as it is. And I also have some test code that I can, properly copy and paste because it's like a boiler template code. I can go through in a bit. Let's see. But yeah, not now. I'll do it later. This is, now for basic parsing. Given a document, just parse it and chunk it and save it in a JSON. That's what we want to do, like, actually. Yeah, it's removing a lot of the code. Yeah, for now, we're not dealing with any VLM for now. We'll add it like in like 30 minutes or something. We don't need anything for now. Like, it just needs to focus on just passing it and saving it. And I need to see what Docling returns. Instruction. Yeah, I don't have any chunking settings for now or configs. We'll just get a JSON first and move from there. We'll save the process in a JSON. Okay, it's just saving to JSON. Source files, yeah, also okay. First a single document, yeah, simple, just document processor, yeah, from Docling, I think. Okay, yeah, looks good. I think I'm going to work with this document. Something that's also old, okay, for sure. It has some tables because we're going to solve tables and etc. We'll work with this. So it's called table man. Okay, I renamed it. It was not called table man. So they'll probably call the aluminium RP or something like that. But just for me to understand, it will be tables. It is renamed. And also, guys, I think I made a small mistake that I forgot to show you what I wanted to show you. So I think I have a conversation. I had a conversation with Claude. What solving for this PDF? Maybe I should pull in that and show you what I planned it for. So definitely get a sense of what's going on. If not, you probably be lost. We have no clue what we're going to build in the first place, I think. Um, I think that's important. Sorry for missing that. Let's come back. It's actually my project settings, chats. It's my projects, series, and use cases and scenarios. Okay, not this, but yeah, solving images for a. So I had this brief conversation. Of course, we discussed whatever the small points, but the entire idea of what we're going to do is that let's scroll down. Maybe just different image. Okay, whatever. So you see this one, right? We have the NTRS document. We pre-process it. We get the nomenclature. We find the symbols. Of course, that's going to be additional surrounding text. And then we have the metadata. And then we put it to an VLM. We get the description. We get the extracted values, and then we save it. And apart from other like probably like it'll look like this, where you have the document metadata. So I just had a brief conversation with Claude. So I guess I sent this particular images and tried to see how Claude is trying to give a description for it, and I think he did a good job. But overall, I think once we do this, we'll plan the architecture, I guess, properly, because I think I have it in my head. I forgot to convey it to you guys. So I think it's very important to be because I know what I want to do next and what I'm trying to do. I'm just keep on doing it, but I think we need to plan this out. So we'll plan it thoroughly and then we'll solve it, right? Let me close this. I'm just going to the logs here as well. Yeah, so we'll just take a look at the chunks here. So we have chunks, we have metadata. Okay, metadata. Let's skip metadata for now. Look into the document, into the chunks, and I want to see it side by side, so we get a chance to see what's going on. Okay, see this. I guess this is what we processed. Characteristics of your problem, and then there's no table. There's literally, let me show you a table, for example. Now this is basically chunk, right? So we're just working on, we're just chunking it initially. I just want to get a sense of what Docling is returning, and this, I guess it was chunking how many, I'm not sure how was the chunk. It was 500 tokens or 300 or something like that. Mm, how much was, okay, and let me show you a figure. For example, let's search for figure. Not this. Okay, yeah, we'll work with this figure. So micron, right? If I search this up, okay, okay, of course, yeah, because you'll definitely end up in. Is it 6? Okay, I think this is just for the last one, and you can see this is the chunk of this particular. Yeah, okay, M500 system. I guess you can see this M500 system, and you can see this particular chunk. And basically, this is just a very skeleton. It's like we've not solved any problem over here. We can generally see how the initial processing, like if you were to use a very general processing, this is what you'll end up with. There's no graphs, there's nothing. End up with something like this, which is what we don't want. So we'll take a very small approach. First, we'll solve tables. We'll solve these tables. Let's also take a look at table one. So this is the general parsing, right? So we just see table. Oops, it was I. Yeah, and summary of metallized propellant. I think it should be in the very first, no, so after the chunks of this. Table 2. Like even keyword search over here is like quite bad. Okay, here. Optimize proposal on bulk density specific impulse. And now this is the table, guys. Like if you were to do in this page, don't focus on the page because Docling gets the page wrong. It's 13, but actually it's 15 because you probably would count it as in terms of 0 or maybe like pages that do not have any text. Sort of there could be an overlap, so don't worry about that. And you can see the headings over here, formulation of properties, which is, I think it's correct. If I scroll up, it is probably part of some, okay, yeah, formulation of properties, but yeah, the general parsing fails over here. You can't chunk it. I'm just trying to show you that this sort of chunking doesn't work. So the general chunking wouldn't work. I'm sure this would probably be the same for any other tables as well. So let's work on tables properly. So it'll be like, we'll work on tables properly. And now the entire plan is that we'll probably, okay, first I wanna show you guys where it captures the tables. As first approach, I want you to detect the tables and then create them as images and save it somewhere so I can take a look. So what I'm trying to do is that I'm basically going to be sending, so I want Docling does a really good table detection, and it'll detect this as a table, and then we'll save it as an image. There's definitely a table extractor, but in my experience using Docklings or any other table extractor, the models just fail. It just fails in very unpredictable ways. Maybe this table is very simple, but we did see a lot of complex tables before, right? Which I will also try to go through just right now. When we solve tables, we are gonna solve tables for everything, for like most of the highly complex tables. So we'll start off with a very simple table. This is like a simple table. What I want to do is that I want to directly send it as an image and send it to a VLM and get a description back. Just it. So um, cool. Extract table images. The hell is this? Yeah, table structure. That's what you want to use. That's fine. The crop is 2. Image scale is also 2. More than enough. Seems good. Okay, so there's if I were to see, there's about if I just scroll down, there's 1, 2, 3, 4, 5, 6, 7, 8, 8 tables. Yeah, and then sometimes the model could assume this to be tables, but that's totally okay. At the end of the day, these are figures, right? So that's totally okay. It can, I think so. I think so. I could be wrong, but sometimes there's a good chance that some of this could be a table. Like for example, this can be a table, right? Like looks like a table for me. So it could be a table. So I'm gonna run this code. This should save images, and then we can take a look at the images and see whether these are right. Like as long as it captures the entire image, that's more than enough, because we can send the image to VLM along with the extracted text, because of course those could be useful. Of course, the text that's adjacent, like like above 300 chunks and below 300 chunks, just for context, I think, and that should work. I think we should have images. Okay, we'll go through them, and yeah, let's go through them one by one. And I think this is table 0, which means it's starting from this. It missed this table. I'm not sure why. Okay, okay, we'll just go through the images. Second image looks good. Third image is also good. We got the entire table. Don't worry about this. We're gonna send these chunks. It has missed a lot of tables, to be honest. Yeah, I think what Docling model are we using? I think there is a way to use a higher parameter model to be able to get even accurate results. Or just let me know what what Docling model are we using for table extraction. And maybe like check the code if there's any other ways of improving this or using any other model. Of course, I'm just repeating what I did mention, but yeah, I'm just an idiot. And yeah, as far as I can remember, it does have like there's 3 tiers of models. One is the easy model, one is the minor model, I think, and it's probably using the default Huron model, which is okay. The other higher parameter models is also not too much. It's probably like under a GB or something, but it's very accurate. We should definitely go with that. And in the meantime, I'm gonna go ahead and test, not test, pull in a document that we saw before. Just make a note of it. It had a lot of tables, like vertical tables. Not this. I guess it was the second one. Not this. These are figures. Okay, this one. We'll work with this as well. Okay, we wanna be able to grab this image as well. Okay, so here's what I found. Current model table from IBM using it for the option most available. Current config always optimal to cell matching true option. Yeah, I think that'll be best. We'll just do cell. We'll turn it off. Um, yeah, we'll test it with the first one. So because it's cropping the images incorrectly, I think that's one. Second thing is that it's enough. I would say it's enough. It's a good crop, but it missed this table one. It needs to be able to look into like extract this table too. Yeah. Yeah, model prediction should work. I think that's the main part of the model because if you want to use like cells, the cells might, for example, this is a very old PDF, right? The scan cells it could have a lot of noise. So I think we'll see here. I think, yeah, but I think still, last time when I did it, it was true. It was definitely had to cell matching true. I think so. I'm not sure, but let's see. I don't see a huge change anyway. It's I would say it's still exactly the same thing. Oh, yeah, thing is, it didn't detect this particular tape. I'm just worried about that. And it didn't detect so. Okay, this is okay. This is right. Page 3. This is okay. This was accurate enough. I'm not sure why it didn't capture this particular table. Maybe it had. I don't know. Let's see. And comparison side. Yeah, I think when it's false, it's much more accurate. No, it's just I don't know. It's the same thing. Yeah, I think it's the same thing. But I say both similar. Yeah, it's very same. Minor differences in column boundary, formulated numbers. Yeah, we was still matching true. It was still matching as true. But for example, I'm assuming it's only because of this text. Uh, I don't know why. I don't know the reason of it, but uh, we'll see. I think it's gonna search for implies purple. Yeah, you should be able to find it and see why it doesn't get it. Of course, don't focus on the page size. They have their own ways of calculating the page number, but it's okay. Yeah, looks like a section link. Yeah, it's not a table to be honest. Yeah, and that makes sense. It's not a table. But yeah, I think it's still okay. It's not like a table, but still, yeah. In worst case, like this is a table, and if this wasn't the table, it can still like you'd be still good enough to chunk it because it doesn't have much of like table sort of connections. Right? It's just text and the text and the text and the text. In worst case, if you were to process this, it'll still end up working. Initial section later limitation of action. Yeah. It's a good point. We probably could do it. I've done something like this, like cropping the pages, but how would you accurately crop the table on a page? Yeah, exactly. There's no bounding boxes because you only if you detect there's bounding boxes. You can send the full image through estimate from text boxes. No, I think it's just okay. Okay, it has bounding boxes. Oh yeah, that makes sense because you have the bounding boxes of this region. So if you just select now the issue here is that now the problem here could be in case the paragraphs mentions about table X, table Y, you would probably wanna you'll probably uh, you'll probably assume that's a table as well, right? How would you differ this a table versus a table X that's mentioned in a paragraph? How do you remove the noise? Yeah, cool. Yeah, this would work. Makes sense implemented because there's always like we have we'll run this. So that is section header. If you were to look at the not metadata, the chunks, this here, you would see over here we have metadata and we have heading references. So in case it's if it's a text, then it's part of the text, right? It's not text. So it's even if it's if you mention this table 7, we don't want to use it because it's part of a paragraph. A section headers would probably be a section header for a table, or maybe in worst case it could not be a table, but mostly the probability is very low. So you'll probably end up with a table. That's mostly accurate. So that's thank you, Claude, as always. Find missing tables. Check if the page already has the tables, similar positions, and you also want to remove that. Yeah, of course. Section header. And this is I won't say 100% accurate, but still gets the job done. Like it does. Let me check. Stable image. Okay, then you extract the image. You have the bounding boxes because it gives you the coordinates of the bounding boxes. Chunks you can still see it. I guess it's in metadata, not metadata documents. So if I scroll down, there's a lot of reference, but you'll get a chance to see the BB boxes here. Yeah, so this is quite accurate. This model is quite good. So we'll go with the change. All right, I think the next run should work. Should be able to capture this table as well. Let's see. So this is a table, and yeah, I'm quite interested. I want to skip this out, and I want to test the first one that had a lot of complex tables. I just want to intrigued to check that. I think it's still missing that table, which we got it. So that's good. Okay, I don't think we need this. Yeah, got it. Nice. It's nice. We got the table. Cool. Then here yeah, we got the table, and yeah, easy. You can extract it. Simple. This is good. This is quite good. Yeah, yeah. Invest. All right, now what we want to do is that now we have the images right now. As I did mention, if you want, there's two options. You can definitely use Granite models from IBM. You can use the IBM's models to extract the table's content. But my experience is that it has failed most of the time. And even when you work with a rocket science docs like this, like even a very small point or very small, I don't know, some very nuance, it needs to capture all the nuances. So I don't want to take any risk. Plus, we're using open source models at an actual deployment. You can spend 2 or 3 weeks, even if you want, maybe like a week or so, just for document processing. They don't care. The first week you can probably spend entire like hours of compute just processing all the documents. In worst case, if you want, because the only thing that you want right now, you don't want is to have inaccurate information, because we know from the personas that we sort of talk to. So it's very, very important we have that. So I think what we'll do next is that now we have the images. Now we have the images. We just have to send these to a VLM. We'll use Together AI and a Qwen model. And yeah, get the description of get a solid, not the description of the image, just get the entire table in a Markdown and also in a JSON format. You should also send the above 300 chunks, the below 300 chunks for more context as well. Yeah, so you get the table and then above 300 chunks to 400 chunks. And also, yeah, also nothing. If you want, you can also, yeah, we'll also send the extracted text as well, in case if it's helpful. But I don't think it's helpful, but in case if it's helpful, we can just send that extracted text of the table along with the image. And we'll also let the model return, as I did mention, JSON, the markdown table, and also most importantly, a notes section that would actually give notes or information on the nuances of a table, things that a table or a markdown cannot capture. Maybe it's vocabulary, maybe whatever the nuances, cap that to, like, I don't know, 50 words max. That'd be the notes section, right? And I've done this VLM wrappers or code. Let me check, because I don't want to spend time researching docs. I already have this code. It's just a wrapper, super simple. Yeah, because I've definitely worked. So the thing is, definitely spent a lot of time just figuring out this basic like this stuff. It's a pain in the. It's really a pain if it just if it works, if it doesn't know the docs, and if it sort of assumes that Together AI supports this and that, and it's just a page. So this is just a template, very simple. Support any OpenAPI AI format, Together AI, Grok, whatever should work. Right now we're using this way. We'll actually use something else, 3B version to be honest. And then what we're trying to do is that VLM image describer. This is just a test code, right? This is just a test code. Optimize image, whatever. So what we do is that it should be able to, yeah, describe it. Yeah, simple test code, guys. Convert it to base64, pass it as context or whatever. I'm just gonna copy this. Here is some um skeleton code for you to reference. Make sure to use it as and take inspiration from it. So what it does is that you basically call in to get the API. You send in. I don't want to write this down. I don't want to let AI do the research. I don't want to do the. I don't want this to write again or sort of make any issues here. So it's very simple. You get the images, you pass them as base64, and you just prompt it to give the description. We'll have a better prompt going on, but yeah, this should be enough for now. Oops. Select this and send it. Cool. Yeah, this looks good. This is what we want. Yeah. Uh, let it do what it's done. Yeah, looks good. Now, of course, it's calling it a table processor. Later, we'll just use one single command to, switch it up. Uh, yeah, just call switch it up and just have one single code that runs the entire parser. For now, we have images. We are going to convert that into tables. Simple. Maybe I'll put this over here, maybe. Yeah, so then you could see. If not, probably my face is hiding the commands. Looks. Okay, I think I can add the E and B. Let's see. Okay. Yeah. Add the key over here. Cool. Let me add it. Cool. I've added it. Oops. Oh, this model actually requires a serverless model. Together, yeah. Actually works. Yeah, models. I think it was. We can't use this model. Probably use something else. Doesn't matter. I think Qwen has been working best for me, so I'm just going with Qwen. As long as you have like a very decent model, it's okay. And this Qwen-VL, I think. VL, yeah, we'll go with 32B. It's better if it's small. And we use. Oops. There. Let me see even if I have any credits. Could be. Okay, it's making. Oh yeah, true. Yeah, but the API should still work. I'm not sure why it doesn't work. It's fine. It's okay. We always, yeah, we'll probably use together throughout. So, and maybe switch this up to a local GPU later. So it's okay for now. And we can still modify the URL. Or maybe it's fine. I would say. So they have models. Which one of the models? So guys, I'm just adding the ENV. I'm just figuring out the ENV stuff. But I don't want to show the, of course, the ENV. Just a minute. Then the variable doesn't work. Yeah, I think it's working, but not an issue with the system prompt. Sometimes Claude is also very dumb. Like it just assumes things and it gives you it starts to update. It just starts being stupid. Yeah, just remember this message. I don't know where this. Just I usually spend hours on this basic baby stuff. Like for example, switching models, API key not there, even building logics for like a ton of docs and tables exception is easy. This is like headache. Shit. For example, it's removing the prompt and trying whether it will work on a 500 error. It will still fail. Oh shit, I don't think it failed. The hell? I got it right. So I think, what was the issue? What was the issue? Yeah, I think it's just to get a AI versioning problem. I was using a different version and you can pass. I think you have to pass it in a different way if you were to use the SDK opposed to the API. Maybe that is doesn't the API doesn't support a system message rule when combined with vision. Yeah, I think it's I mean you can still do like a user message and get it right. If it works, then it's fine, but it should support system message. Probably has to be I don't know what's going on to be honest here. But it's okay as long as we get a table back. Okay for now. We'll come back to this later. It's fine for now. Process all the tables. Also, it's fine whether it's system or user. Make sure even in the user prompt include the entire prompt that was originally written, and also make sure to check in for notes on nuances and etc. and pass it properly. Yeah, actually pass PARC. Yeah, I think this should work. And even without this prompt, like usually I don't do JSON table prompts like this. It should figure out, like the last time it figure out. It's okay. You can still have notes and JSON. If in case you want, you actually the thing is you don't need JSON at all. Markdown and notes is more than enough. But it's okay to have a JSON in case you want to in the future convert these into searchable queries in Quadrant. Then yeah, of course JSON is useful. But for now it's just not. But we'll just have it, not an ARM. And also like whenever I do this stuff, like for example a lot of the people outside, like you'll be probably thinking of optimizing this and using very less amount of chunks to build this up. The thing is it's not worth the cost. What the hell? Because it's failing again. I think it's a max token limit. I think because max tokens too. Yeah. So what I was saying is that it's not worth, like you can't miss even a single nuance in this science documents. It's very it's really huge. Like you just can't even a very small symbol or a mathematical equation will cause a huge disruption in your accuracy. So then what we do is that we try to gather as much as information as possible. Even if it's spending tokens or money to VLMs, it's okay. That's the priority for us. And plus we are running it locally, so it's just a matter of time. Like we can run it for like 2 weeks. That's still okay for us. Yeah. Okay, I think it's an API key problem. I'm using a different API key one. I know what is the problem. I think I'm using a different account and this doesn't have. Uh, okay, this okay, create an API with this. Get the env. Guys, I'm literally not sure why this Together API is failing, but I have some sample code that I can use, I think. Some sample code. Maybe I should send the sample code, check this out. For one of my projects actually. Yeah, I'm not sure if it's true. Yeah. I don't think that's an actual problem, but yeah. Let's see. Sure. Yeah, I think, yeah, again, we don't still need JSON as well, so just give JSON, but I'm not sure why, the reason why it's failing. Such a simple problem, but yeah. Yeah, run it and see. You, I think we're using this model. But I can see it doesn't, Qwen's only one of the models is the V models. The VLM models was only V version, I think. Oh no, it does have, okay, the other ones. Try this. Okay, maybe it's because the model was not available. Yeah, let's make it 32 and also increase the max tokens. Okay, so we're getting it. Cool. And also, because and max tokens, 4,000 is more than enough. We just make it 10,000 just in case if there's a big table, or maybe even with a big table, you wouldn't have output tokens of 10,000. Just to be on the safer side. Even 1,000 is more than enough, but yeah. But let's test a full processor, and we just spent like 30 minutes for like an unwanted issue, like API key issue or model issue, whatever. Most of the time, that's how I spend most of the time. For example, right? Okay, that's working then. Okay, footnotes. Yeah, and you see the notes here, right? The A it equals to 400 series, 200 series element in powder. B likely refers to specific propellant. Down arrows are okay. Now the thing is like this: it misses symbols, and that's what I was talking about. You need to extract symbols, and most of the documents do have symbols. So we need to just extract the table. We'll come back to this later. So this is okay. It's just assuming some things. This could be better once we have the context on the symbols. Um, okay. Run the entire table images. And also together, I guess I only have a little bit of credits on that, and maybe I have some of my requests are being rejected if I can't call it in a given single minute or something like that. Maybe that's where you can see the rejections over here. Max tree exceeds. I don't know why it's being rejected. There's no, but some of them passes, some of them works as well. Maybe it's because of the images dimensions. Like the dimensions of the images could be different. Maybe that is the thing. You can see it successfully extracted for 12 by 6, 12 by 9 on all of them. One of them was unsuccessful. Successful was missing table. Okay, passing still okay. It's a stupid together AI problem. Those guys, the API is rejecting some requests. We'll move to different provider later. I think open router is good. We'll do open router or whatever. For now, it's okay. It's as long as it processes some images, it's more than enough. Okay. You can see this image. There is no notes. Okay, there is notes as well. The broken visual column is split into two columns. Okay, good. Okay, the accessible servants, mistables one is also processed successfully. Cool. Output includes, actually, I would say, do not have detected tables and mistables in different array or JSON. Merge it into one and process everything in a given on a given time or a single go. On a single go. I can see over here. This is a mist table. It's okay. It's not a big deal. You can see the rows. So rows are not, the rows are coming from the model itself. But this is what we want. We want the markdown and we want the notes. We don't need even JSON. We can extract JSON, but we just don't need it. It as I did mention, if you want to put it to coordinate and search via certain variables, then fine. But no, I don't see a good point to use JSON for now. So we'll just leave it as it is. So processing is working. We can see all the markdowns. And if I go up and see this, so these are, so for example, what I'll do, I'll just copy this. Actually, I'll not copy this. I just need the markdowns of each this thing. Okay, let me tell it to close a bit. And I think it'll merge it and run it through a VLM. Library destroy this may cause a memory. Okay, we'll figure this out later. It's not a big deal. And you can see the headers as well. This is directly coming from the model. We don't need to use it. Still the same logic over here. Yeah, we'll process it. What I can do is that Gemini can handle this much of content. What I'm going to do is just pass this to Gemini. It's just Okay, now the thing is tables are not in order. You can see that. I will actually use to open the tables. Use the headache. Yeah, because I think if it rejects a request and then it's running it again and it's too much of a work. Anyway, we'll see, check this. Not this tables combined. Prints is fine. Okay, this is the combined table. The only issue here I can see is that this is not in order. These are in order, I think. Yeah, 3 failed due to 500 errors. So we'll just switch this. I think it's important to change that. Let's see. Open the instead. Context 7. 2. I'm just gonna share the API key because if you want to, I don't have much credits to be honest, so it's okay. Give them the models then. We'll do chat. Qwen-VL 32B. This is, yeah, this is okay. This is enough for now. Change the ENV, so cool. Cool, I think it works. Yeah, we don't need to have the headache now. I had some credits to get this, that's what I use it. Yeah, and also not a problem actually. Maybe this is the only problem because three of them failed. So we'll wait and see why, and also why it did fail. And we don't need rows, we don't need headers, we don't need anything. We just need markdown and notes. Simple. But it's part of the same output, so it's okay. And you can see all the requests are successful over here. One has failed. No, no. Okay, this is okay. It's work. No, it's work. It's not working. Okay, it's suppose I guess we okay. 8 tables images process. 6 or 8 failed. 5 2. Okay. So two of them failed. I'm not sure why it did fail. But let's see. Okay, so I guess we need to retry it. We'll do a retry request. Mm, yeah, I've seen this table. If you want to go to formulation number, let's see that. I guess it's this one. No, not this. Okay, this one. Yeah, seems like it's an accurate representation. Yeah, and this also makes sense. A to F are referencing table, but not included in the markdown. Some of them could be solved just with symbols. Let's process it one more time and see. The thing is, all of these issues will be solved once we batch all the requests. So what we can do is to do like a full batch and run everything in a single batch. So you don't need to, nothing is dependent on anything, right? No context needed from the other API calls. You can just batch it up and run it in a single batch. It'll save you money. Not on, if you want to run it locally, it won't. You'll still add up context, but yeah, if you want to use API, just run it as a batch. It's a smart way of doing it. So I think that is okay. The table. And I think that's why better off we just use models running it. If I don't know whether it's an 8 billion model parameter model, but I think I should have run it. I should have. I could have just run it on my computer. I think they've been easy because I don't want to deal with all those API issues. Yeah. So third try did work. So that's the issue. Like you don't wanna waste a lot of time in just APIs. Yeah, it's okay. I'm not sure if you can change it to change from together as a backend router. Yeah, I think Fuzzer, yeah, that's true. For now, we can use Gemini, doesn't matter. It's a Flash, still it's an open source model. I think I would say it is. Okay, we'll use this. I guess it's using cloud, Alibaba Cloud, and should handle requests much more gracefully. I think it, yeah, it did. We'll use this one. It's fine. I think it's still at the end we'll anyway run it on a run by GPU and just take care of the request part. So yeah, no point wasting time in this. So let's do that. I think what I can see right now already processed tables because I've gone through the doc, and this is the last one. I think aluminum spec. If I scroll down, no, yeah, this one, yeah, no, I think it's before last before one. Still three. And you can see all the requests are working. So we just stick for it now. Later, anyway, as I did mention, we will probably rent a GPU and then process it overnight. See, yeah, this to Alberta it's a bit slow. It's of course it's a bit slow, but it's okay. We can batch it anyway. It doesn't, it's not an issue. Yeah, we'll see this. I would say. Okay, I think. In the JSON, I do not need rows. Uh, I just don't need rows. That's okay. And I need the JSON to be in order. So, for example, I want it to be in the order of the documents, not jumbled, because I don't want the fifth figure to be on the first figure or something like that. We want to capture the same order as well. That's the best. So, right there. Yeah, this should work for all the tables except the tables that we do mismatch. Um, First table. So this might, I don't know where this might end up because you can never know because it's the missed one, right? Missed table sort by page, then index by 0. This is okay. This is enough for now. Yeah, because at the end of the day, you just want to, because anyway, pages doesn't matter for tables here anyway. Like in a sense, eh, like a table from the third page or the fourth page might be needed for the AI. It doesn't necessarily need to correlate or be in the same order. It should be. It's good, and like 7 out of 8 times it's in the same order. For but missed pages, we just try to put it. We just try to find the best order for it, and I think this would just put it in the first order, but not sure. It might work, not may work, but might not work. It's okay as long as this is inside chunks. There is no need of any relevancy in the hierarchy of the hierarchy or any tree connection. You don't need to have that map of what is first, what is second, what is third. Once you get the first table, we have a fallback of the entire section or the metadata. From that, you can pull the other tables by just a simple search on tables. So it's okay. Models can figure it out, and it should be fine. I think for now it should be fine. So let's see. And pretty much we spent more, and it's quite funny as well. We spent like brilliant, like probably like 1 hour just figuring out this together issues. We just completed the entire table extraction in a few minutes, like 15 to 20 minutes. It's um, I don't know, you usually spend like those API issues, like you can't really figure out things. These are like you can figure out, you don't know why it goes wrong and why it rejects it, and you just end up spending more time. So that's what I usually most of the time run embedding models on my PC. Just don't waste time in any stupid API calls, and all of those VPN blocks and everything. Simple, it just works, and then afterwards you deploy it somewhere and just just get it running and host it somewhere or express it somewhere. So you will wait a minute and check it. In the meantime, okay, it's done. What I wanna do is to just use Claude, maybe use Gemini or something. Maybe use Claude, right? And then we can check, go through one by one, format this properly in an MD file. Yeah, and they should give us the tables, and it will say it. And you can see it did put like this. The first one was a missed table, but it's still on the first row, so the order is working fine. I guess it did it to page row, or maybe because you can do it with page rows. You also have bounding boxes. If you want, you can use it with bounding boxes also, but there's location issues. Bounding boxes are the most accurate way of doing it, and also very reliable. You have the exact numbers. You can easily figure out even once bounding box, even if it goes by one or more less in top or right, you can easily figure out, okay, this is what's going wrong. So it's okay. It's not, we still have workarounds for it. Oops. I don't even Claude doesn't issue me complete. Use GPT. Okay, and I think you can see it now. First one table seems like it does work. It is right. And this is slow. What I'll do is Gemini. Yeah, this is taking forever. Okay, this is fast. Cool. Now we got it. So this just you can see over here you have some summary of metallized propellant. I can't spell it, but yeah, requirements. You have the formation, stability, and all of these documents. You will scroll down. You'll have we have this table too. Oops. Okay, so this is missing. No, this is actually not missing. You see it over here. You don't know. No, guys, I guess Gemini is skipping it. You can see it in Claude. This is table 2, this is right. You can see 60, 58.4. You can see 36, 20. So this is this particular diagram. So this is right. Let's retry this request on Claude. And this is table 3. Table 3 is also huge. You can see 942. GL, you have separation over there, F. And if I just scroll down, you can also see all the numbers. It's very accurate, not measurable, looks very accurate. And also you see the lines over here, those are going to be captured through nodes. So that's okay. You will still get it right. This is okay. I guess I should have Claude work on this. Let's see. Yeah, Claude doesn't respond, but it's okay. Gemini skipped most of it. This is fine. This table 4 is also very much big. So scroll. And see this one. This is 3 and 4. 3 shows the state, the person's solid stability, the density, shear rate, and all, some of the words even I can't pronounce. Yeah, looks very accurate, very accurate. Table 5 is also the same thing. You got it. Table 6 is also the same. You can see most of it. And don't worry about this. This notes will be quite accurate. So even though this doesn't have an accurate representation, the note should be able to provide more value, like more context over it. And scroll down and see this. This is also quite accurate. I can see 941 has 1 December, and then you have the share rate. I don't know how you spell this, but yeah. Again, same thing for table 8. So it's it's very good, I would say. Yeah. So yeah, table processing is something we've already solved now. So it's working and it's giving an accurate representation. I have to see it to render this one in an MD file and show it to you guys. Just to verify for myself as well. And then I can render this and check the entire markdown. Okay, so I'll open this, not this. And here you can see, this is fine. The notes is also good. And you see, if I scroll up, let's go one by one. Just put it like this. Looks good. This looks good too. And you can see the reference over here as well. If I scroll down, this looks good too. You can see over here. So here separation F is indicated with a downward arrow according to the gel to the low formation. Now the thing is, yeah, this should work, I think. Yeah. There's, I don't, the line is not yet here, but I think we could send the image as well for it to accurately understand, because this cannot be like perceived through just a table, no? So it's okay. If I scroll down, page 2 table, gel separation F, and you have the footnotes over here. That is also okay. You have the fourth table. This is also seems fine. V table is also fine. This is also a huge table. That's accurate. So most of it is very accurate. Yes, like it's like really 100% accurate. Opposed to the only line, because in a markdown you can't really literally like, you can't show like a line over here, right? But that's okay. This shows is indicated with a downward arrow pointing the gel to lower formulation, suggesting phase separation. So I think this is table 1. Yeah, you can see it didn't account for separation F. I think we should yeah, it should show it. Let me see this. Yeah, it didn't show it. I'm not sure if you can show. Okay, it did show it over here. Second one. Yeah, okay, it did show second one. I guess the first table formatter in our formatting has an issue, so it's okay. We can see separation here. Yeah, I guess mostly it's very accurate. So tables are something that we've solved, so this should work. Now we'll try it for this table, which is enormously very complex. Vertical height tables. So okay, now test it. This okay. This is all good, but then now this is very complex, like very complex. I'll just run it. I would like to see the images as well. It should throw out the images here in sample docs or tables. The same ID, it's okay. Let's see. Okay, it only extracted 3 tables, but there seems to be there's 4 tables. But let's see. And yeah, wow, this is good. You can see over here. This I guess it's first table, and it took it really nicely. So table 1, very good, correct. Table 2, this is also the full table, which is very good. And I think table 1 continued. That's table 2 continued. Table 1 continued. And table okay. Okay, it's a continuation of the table. Oh, it's still okay. Okay, now is an issue for us. Now it's a continuation of table. You can't process each and every. No, you can still process. Still, it's okay. It's just Markdown, right? You can still process, but it missed the 4th table. There's 1, there's 2, there's 3. It got the third one, I think. No, it didn't get. Yeah, it got the third one. This is the third one. You can see over here the you have a pipe. No, not the third one. If I scroll down, yeah, this is what it got. So you can see 14, 12, 11, 10, 14, 12, 11, 10, and this is 10 starting from 10, 9, and 8, but it missed this. It missed, I don't know why, how it missed this. Maybe it's a single page or something. I'm not sure. We'll still get the we know yeah, we know the issue over here. We'll still get one single table and see. But so far I think it's quite good. Not up to the mark yet because it missed one table, and we have to spend now hours trying to figure out why it missed that one table, because we don't know. The model makes the predictions. uh, and this is also very different table, like it's one table because you can't scan it in a single PDF. It's vertically added towards 4 pages. Now I'm not sure how you could even make sense of it unless you visualize it and check the first 2 3 pages, un, or it's like visually until you hit the next table. It's probably, with the current context you have, probably part of the same table, something like that. Like that's how I can visualize. And also VLM should take some time because there's so many figures over here, so it'll definitely take some time. Let it take its own time, it's okay. That's what I told you, right? You you will definitely, you will 100% and definitely what do you call, not definitely, you will definitely run the VLMs if you were to host in an actual environment for weeks, like easily. Just see the number of time we're spending just for one single document. Depending on the hardware, it could be even more. It could be weeks, easily 1 week more. Not like 24/7. I don't think it'll work 24/7. You still have to do a lot of batch processing, parallelization. If something goes wrong, then save that checkpoint and you process from there. That's very different. That's like an infra problem to take care, not necessarily an AI problem, because AI problem is very different. As long as you solve tables, it works. But yeah, the other environment is very different. Solve for that. I just thought I should mention it because yeah, it'll seem like it's very easy, but yeah, just see for one document, um, it's taken more than 3 minutes. Of course, it's API issues and scale, whatever. This should be even, yeah, you can cut it by 50% easily. If you're not using API, if you're using running the model entirely on your computer, it should easily work. And I think we're using VL Max, which is also a big model. It takes the output token time is also very less. But it's fine for now. We just need to use a VLM to get the get an accurate representation, and then we can move on to the next. Okay, finally we got some processes done. Looking to the extraction JSON. Yeah, looks very huge, but only three. We've only got three. But it's okay. I guess Claude is down. Yeah, I think there's some partial outage. Yeah, and we'll do it in a markdown this thing, and you got this. Cool. I'll expand this VS Code a little bit, and you can see table 0, page 9. Don't focus on the page 9. Pages will be different. I did mention before. And it's even hard to visualize 1, 2, 3, 4, 4 pages, and see the first one. Right, table 1, experimental data. You have so much information, and like there's no way it'll go wrong most of the time. And you can see I'm just gonna visually now, I'm gonna visually spend time over here. Of course, um you should do the same thing. There is no evaluation framework here. You can't drop in the document, and you can't drop in whether it's right or wrong, because of course we are itself building the groundwork for it, which can serve as evaluation framework. So there's no you have to manually do this sort of checking, because there's a lot of intricate parts. So if I and also I think do not have a a limit for notes when generating tables, because I think it's limiting for 50 characters. There could be a lot more information which should be captured. So we'll do it. It's fine. It should work. It should accurately work. And you can see, and it's a representation. It's exactly from the model. I can easily verify it. So it's just check damp, unstable, and 15. You have damp, unstable, and 15, which is part of 131. Okay, what is this? Test number 773. Unstable, second one 774. Yeah, and it's right. And you can see it. And damp, and you don't have any bomb size or require or stability classification for this. If you scroll down, you can see 65, and 65 has damp, unstable, and also 15. You can verify it over here, which is in the second line, 65, and you got, oops. And you've got for 65, I think you've only got damp and not unstable. Yeah, it's wrong. Oh God. Yeah, I thought it was right, but it's actually wrong. So see this 65, you have 10.780, you have 10.780, 1.9, 1.9, 50, 1009, 9.25, 10, 18.50, 2.0, and then you have all the blah blah blah, and then you have 54, 2.8, and damp unstable 15. When 15, you can see test number 15, chamber this diameter is 10, and you have, in fact, you have everything is made up. Oh my God. Oh, this is totally wrong. It's totally wrong. Because you can see there's a lot of connections over here, right? Lines and lines and lines. It doesn't, it like seven, I can, like, I'm looking through the horizontal lines and I'm coming up with the conclusion that 774 has unstable 50. 30 it doesn't have unstable, but the model doesn't know that there is stuff like that. Like, there is no, like, there is what do you call, there is a like, for example, scroll down, you can see that there's definitely a curved line over here and says damp, and there is no unstable, but you see the model noted did have unstable over here, which is 100% wrong, like super wrong. And for 65 there is no 1.9, 1 point, wait. Oh, no, actually this have 1.9. You know why? Because, no, this is accurate, because this line, I think it represents that 10.78 is 10.78 for all the figures. So then, yeah, this is right. Yeah, this is right. Except it did make a small mistake of saying damp. Uh, oh no, oh no. I think it's unstable. No, it's not. Then it's damp unstable. So you have damp and you don't have damp and unstable. I don't think you have damp and unstable. Uh, which is a very critical, very minor this thing, because you can't get everything right. That's how the assumption, but this is like 95% right. You can get away from this for now. And what you can do is that for images like this, which is very complex, we have to tell them, we have to store these as images as well. Like, we need to store this as images, and also let the model self reflect and say a complex diagram like this, there's a good chance that I might be 80 or 90% wrong. Then you just show the images, like the you don't necessarily, you don't give the exact markdown, you give the markdown along with the images to the agent. So usually why we're doing processing is that it gets the markdown and it reads the markdown, right? What I want to do is that for stuff like that where there's so much of connections, right, I want to send the markdown and also the image as well. And yeah, just for like double verification, and show it to the user as well, because this is like very intricate. Like, you can't, like, like it's Oh, what can I say? I don't, my English is also bad. So basically, so far the model has done very good. We can't expect more from it because it's actually a visual issue. Like even if I give it to Claude, maybe Claude will solve it, but I can't spend that much of money, running Claude. And also in an open source environment, you can't run Claude. So you have to stick with these models. Then you know the limitation, then you work towards the limitation. And what we can do right now is run this table. So that is, yeah. Yeah, there's a 50 word limit. And like the VL Max itself made this mistake. You just think about it. I think it's a higher parameter model. I think it should needs 1 or 2 GP. I'm not sure, but this is very accurate, like quite accurate. But we can get away with this. And also, if you see, we missed one single table, right? Now this is the main problem. Why? I'm not sure why it's missing the second table. There's actually three tables. There's a lot of problems here to solve. So I think this entire stream will be solving for this, so it's okay. Yeah, have no limits. Because sometimes you want to explain even more, so let it explain. Yeah, but actually say we have no limits, but tell the agent to be brief and also cover all the important aspects and the points as well, because accuracy is important here, and find the sweet spot. So I don't want you to write an essay on the notes as well. So keep it keep it clean and let the model decide. No, we'll just leave that. We don't want to reset. I want to ask what Qwen models. Okay. Or yeah. Uh, yeah. Now you can see this easily. Like so much structure, so much going on. Even for a human, it's very hard to understand. Easily very hard to understand, and you probably sometimes even you might even need a ruler to match out. For example, 294. You probably need a ruler to match out. You need like a big ruler to match out, and we VLM easily will not get it wrong. What we can do is, guys, what we can do, one thing what we can do is that you can see these black color lines over here, right? I'm not sure whether I'll do it in this stream, but what we can do is that because we know the test number and IDs, what we can do is that we can generate like horizontal lines for each gap. For example, see this, right? We generate another horizontal line for each gap, for this another gap, and you'll have another gap. Not sure how you can do it. We can't use an LLM to use it, but what we need to do is that we find the bounding box, right? And we know, for example, let's say this 255, and of course LLM needs to analyze it. It should be a pre-processing step. So, but see this 255, what we can do is that this IDs, they have a format, right? What we can do is that there's a gap between it. There's a pixel. You can dissect it, but dissect this image. At the end of the day, it's an image. Dissect it at pixels. Let's say it's pixel 1, pixel 2, pixel 3, pixel 4, pixel 5, whatever, X or Y, whatever the number you want to talk about. Get that X value and see this line over here. We put a line over there, very small line. We put a line over there, and we do it for all the numbers, like until it goes on. Even if it crosses the entire table, it's okay. You put lines, lines, lines. Now it becomes super easy for the LLM, because right now we know that 295 is actually 316, because we right now we provide a structure or maybe some ground ratio. Then it will actually make sense with the LLM. We can do something like that. um I done something similar for graphs, but not for this. But you can try to do something like that. Let's see if we can do that later. uh I think I would have been better off running the models locally. Like, tables are the most hard part. Like, these are simple. Like, compared to tables, they're like baby stuff, to be honest. Like, way harder. I think there's some issues with Cloud Code. It's so slow. My Wi-Fi is very good. Not very good. It's decent. Some issue with Cloud. Yeah, so they're having some major outage. 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 Such a bug. fine. No, we'll stick with this. Let's not focus too much on the models for now. Models, we can just change it. We just need to focus on getting this stuff accurate. So there was, to be honest, there was 3 models. There was actually a lot more, I think. Oops. There's 4 tables. I know the model can't read this, but I just to prove that there's like 4 tables. It's fine. There are 4 tables. Only. Yeah, I don't also want to spend too much time inside this as well. Because we can come back to this a bit later because solving tables is taking a ton of time right now. No, I think the image dimension is very different, and these models have doing it. Let's say yeah, it could be a maybe Docling approach, like Docling approached in the right way, or maybe Docling took it in the took an actual API, but maybe I'm sorry, Docling exported the table, but then Qwen failed or something. I just want to make sure that it was not the case. But yeah, but that's true. We only have 3 tables, images. Yeah, that's true. And it can basically check extract the table and see, because you could find the table name pattern, right? And then you basically could check why it missed it. Or maybe section, even section header. It didn't even catch the section header. Maybe it's not in the section header at all. Yeah, that's the thing. Yeah, tables are very, very tough. These stuff are very easy. And you literally see this is like quite easy, right? You can embed the image, show it as a figure, and then pass it to context, and it should work. Doctoring being able to process that is like quite tough. Yeah. Yeah, we'll be like first and the last one, check everything in between. And you should, I guess, it'll anyway pass and check it. So first and the last one, check everything in between. Yeah, I think there's some issue with Claude, and yeah, it can't process images. There's something of an issue. So I think okay, I think I wanna run it once more time. I wanna run the document processing one more time, not the Qwen, but the Docling pipeline. And Qwen Qwen, it's okay. It'll get it. Makes sense. Okay, okay, so the second one is actually the last one. No, the first one. First one or last one? Is the first one. The second one is actually the first one. It's 10:14, right? Yeah. Yeah. Just drop some. There's an image before this. There is an image before this, or a table before this. And you can see it's concluded. And highly important. Thank God we even stumbled upon this, because we would have assumed the normal tables would work, but like that's one of the reasons why I took this diverse amount of documents, because tables are different, images are different, and yeah, whatnot. Maybe there is a different way of run. There's a different model as far as I can know. Table model. And I guess they released a better model. There was another model that they did release. I'm not sure if it was recent or the last time I checked it, but there was a different model for extraction, I think. Okay. 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 It assumed that it's a picture instead of a table. Okay, if then that's the case. We need to process that as well. Then we can, yeah, it's still simple, right? Anyway, we're sending it as an image, so it should work. Let's check this. And yes, this is right. Um, so we have table, let's check the images then. Table 0 starts with 762. Second one goes, you can see it's 6 and 7. It has this 292 thing. Uh, yes, and it's 6 and 7, and you see in 292. And then you come back to 552. Let's see, it's 552. Yes, it's right. And then we have 427. Nice. Yeah, got it right. Cool. Yeah. Thank God it's working. Cool. I mean, yeah. And this is just the tip of the iceberg. Like you would also work like you might even come across even more issues. But I would say, as far as I've seen some tables as well, complex one. This is very complex. If you were to solve something, a table for this, like if you were to accurately solve tables like this, 90% of the time you're covered. And these are nothing, like these are very small babyish tables, like you can easily figure it out. So yeah, we got 4 tables, and that's the only 4 tables that we have, and the others are graphs. And next, let's move on. So I think we've solved tables. Let me see if you wanna run another. This doesn't have much tables, very small baby stuff. Um, if there's any other tables, these are graphs, these are images, not tables. You can figure it out. Scroll down. These are graphs as well. Uh, and this has very small tables. This would probably be nothing for the VLM to handle. And this has tables and it has formulas. Cool. So I can confidently call this off as it's something that's working for tables. Yeah. And I think the second we will update the document, I think. And we can start working on the rest, which is, I guess, figures. Yeah, and this is done, and table extraction is done. You have formula extraction. Yeah, let's do formula next, and it's very simple as well. Like we have a good pipeline, we can probably do something similar. Picture diagram processing, same thing, and then hierarchical thing. That's something that's the Docling already provides, so not of a big of a work. It's probably simple. And then we just need to extensively test it, and we sort of have done pretty good work on the set of documents we have, very diverse documents, being able to being able to identify tables even at this sort of complexity is quite impressive. Not impressive, but it's decent. It's not 100% accurate, but we've got there. Yeah. So let it run. Let's scroll through. Okay, Claude is still down. Yeah. Because usually, of course, you can literally, I mean, you basically could export it and see it as like you can just export the markdown and see it. But I have this, I tend to just copy paste it in, but you just copy paste and let the LLM late chat, I guess. Yeah. LLM output it, and I just like to see the way I could just observe things, and some of the times, even if you do it via Markdown, you might miss a lot of things, right? This could also take care of the notes, and the Markdown could be even much more better because it has context of the notes, and that's why I usually process it. So we'll give it a bit of time because it's a huge this thing. It's accurately picturing this out, so it'll take a few minutes. Let it be. So it's already 4 minutes, and of course, yeah, it's a big model. You just yeah. And it's 4 minutes for like four tables. Like it's probably like a minute for a single table. You can just cut it for like 10 to 20 seconds. You can get it in 10 to 20 seconds, depending on the model you use and also the inference provider you use. I think this is very slow. Alibaba is quite slow. Yeah. I guess it's the last image. One, two, maybe no. There's one more image. Cool. Let it work on that. I think it's most probably it's gonna be accurate. So I would probably maybe I could work on we'll just work on extraction. It's taking a little bit of time to process. I would just say make sure to do the extraction code and development plan. Next, let's work on. Yeah, actually maybe I'll just wait it out. Oh, no, verify table first. We'll just I'll just take this a bit slow because I want to verify this table works. But if it doesn't work, then I have to come back here and work on the table. I think it should work, but let's see. I want to see if I want to if there's any other table that I can test with. These are very basic tables. Like these like this is how the recent documents will be. You have it in Excel or you have it in this sort of PDF. Very easy. You, I mean, you don't need to even have an LLM. Like with the metadata and with this, like that's what we enable through cells. You can get it from the cells and you can easily predict the generality of the table and form it into a table. This is very tough. This is one of the worst tables I've ever seen. Very complex, very huge, but also you can't miss any info. Like you can't afford to miss any info on this. So yes, okay, this is good. Four out of tables issues are solved. It's huge table to be honest. So this is huge. What I'm gonna do is too. I just want to see this generate along with I guess notes are also available. So okay. I'll see the table, I'll see the JSON. Yes. And you also have the notes. Make sure we like make sure check notes as well and format this table accurately. I'll paste this. I don't need think, I just need a fast model to render this. Simple. Okay, this is good. This is okay. The hell? Oh no, this is not this is not doing a good job. Anyway, we'll stick to this table's general open view. Yeah, there's a small glitch in this, but that's only because of the preview we have generated. This is okay, natural. And you have the notes over here. And I want to see the third one. That's the most complex one. It's the most complex one. So we'll see the third one. This one. Okay. It's from page 211B, and it's five. Let's go one by one actually. Page one. Oh, I guess we have a huge error. Yeah, it's definitely hallucinated a bit. Not a bit, a lot. Page one, and this is VLM extraction page one. I think this is page one. All tables page one. Yeah, entirely wrong. Entirely wrong. This is accurate. I think page 12 is accurate. Page 12 is the last one. Transition. You have transition as well, and the ending number is 33. Mhm. Now we'll actually change the model a bit. There's an issue with this model. We can wait, and we can wait if there's any issue. The old coin was 3B or something like that. Let's see if it's a model issue, or maybe it's a parsing issue. I've never faced anything like this before, so let's see. Yes, of course it'll fail, but we can retry it. We have mechanisms to retry. What model are we using? We'll use this one here. No, I don't think it's the version 3, this one. Let's try the third three. No, let's try this one. Let's try this. Now we can validate whether this is a model hallucination issue or maybe it's most probably parsing issue, but the images are right. Maybe I don't know why it's an error. What we should do is that we should send the extraction. I think we're sending the extraction as well. It has given the lines, but it missed to like it has missed most important part. Like this is like totally wrong, and the ID is also totally wrong. So I assume it's a model issue or some parsing. Let's see. Let's validate. Okay, we're getting timeout errors because it'll take each request takes a lot of time, right? Because it's doing for the entire tables. Yeah, we can batch it because we don't want to waste time sequentially waiting for our table to be passed. Phone lo பார்க்குறீங்க எது GB No, no, just useless amount of search to be honest. Go ahead. No, okay. This one. Actually, this allow batch processes. Anyway, we'll do it for sequence. We will run. Yeah, batch meaning we'll just increase the timeout for now and run parallelly. Then it's basically like batch. Of course, we won't save any cost. It's basically like four things running on the parallel. It's okay for now. Right. And the model is fast as well. It should respond in 180 seconds. It's okay. Yeah, let it do. But we'll refer to some other. We'll just go through some docs as well. These are fine. I don't want to process them. This is also okay. So, this is a very basic document, like just images. We'll figure out figures, then it'll be easy. Not an issue. Tables are the most tough part. Uh, and also tables. So if I scroll down, you can see a lot of images. These are scanned. We can never support this stuff, and the BLM wouldn't understand what this is it. But we can support stuff like this. Like this is very clean. It's a very clean PDF, very clean scan, good scan to be honest. So we can easily support this, and all of them are not tables. These are figures, um, or images. Yeah. You can think of this as a table or a figure, doesn't matter, but it's almost like an image or a figure. Or what you can do is that, guys, sometimes if you want to make it more accurate, uh, what can you do really? You can convert you can assume tables to be figures as well, and then send everything, each and every figure to the VLM, and then predict whether it's a table or an actual figure. If it's a table, Markdown is more than enough. You might not need an image. If it's a figure, then you would need to generate descriptions and then embed the image and save the image. You can still do both, but still it's an additional cost. But end of the day, we are still sending table figures, everything to the VLM. So you just you just send everything, like whatever comes up, the table, graphs, whatever, just send it to a VLM, let it predict it, and on point give it a description. If it's a figure, and if not, it's a table, then give the entire extraction. So successfully extracted this image. We'll see the tables. So so this is right. That's the first image. 7722. This starting with 722. That's okay. It's correct. And this is the last one. Hopefully this will work. Let's see. And also when we slide this thing on embedding, when we embed them, we won't split this into chunks. Even though we have 500 chunk limit, we'll override that, and each table will be one particular chunk, because then only it'll make sense. Because just see this entire table. Like there's no way you can search for things like this if you split this into chunks. So we have to think about different chunking strategy for this. Let's see. I don't know. We have to plan something different. Let's plan something very different. So let's see. Yeah, still we have another. Oh God. One request has failed. It's okay. We can increase the timeout. Or maybe it'll retry or something. Okay, it's working. Let's see the JSON. Extraction JSON. Let's see. Yeah, this is incorrect, guys. Very much incorrect. I think it's outputting really it's outputting really I don't know. The output is quite inaccurate. Give me what info or context are you passing to the VLM, and are you changing the image size or cropping the image before sending it, or are you sending it as the full image with full resolution? I need to know everything that you do in the backend. Let's check the code ourselves. Let's do this, guys. Maybe the formatter, when we detect the table, when it actually makes the prediction, it's probably wrong. So, and let's not send the broken markdown. Don't send context before and context after, and do not downscale the image. Send it as raw high res image, please. And also I would want to know, will it now generating markdown for a huge table seems like it's quite tough for the LLM. Would it make sense if it generates a JSON, and could we use the JSON to generate a table for ourselves? Like, could we use some sort of package to use the JSON to convert it to a table? And will generating JSON be accurate from the model opposed to a table? Just want to know more on that. Yeah, we'll do JSON, guys. Let's not do Markdown. 100% those. And let's say even if the Markdown, if it's empty, it needs to do the spacing, it needs to give it the lines. JSON, you just don't need. Yeah, we'll just proceed with this. Yeah, let's proceed with these changes. Now we'll just, yes, send them in full resolution and convert it to a JSON only output. And of course, use tabulate to generate markdowns. I think this will be accurate. Let's see. And I sensed that maybe it's because even one small extra space could topple the row, and if you topple the row, then all the IDs could be messed up and etc. Right? We don't want to get into a problem, so we'll just JSON. And we also know for a fact that JSON outputs are also strict right now, and hopefully the model should emphasize on more JSON, and JSON should be accurate. But let's we have to see. We can't be 100% sure. In case we don't need to process the images, we don't need to, of course, we already have 4 images. We can literally use that. Uh, yeah, do that. And I don't think there'll be any issues for not downscaling the image, but we have to wait and see. And we get markdown rows, numbers, raw response, and then yeah, so we could have clipped it anyway in case this doesn't work, but it's okay. We'll just yeah. Another issue is that if it gives wrong JSON, if it gives an incorrect JSON, then that's another an issue because Qwen is very good at creating inaccurate JSON. But anyway, we'll give it a shot. The first markdown was very accurate. I don't know what happened afterwards. Okay, I would say we already have 4 images saved. Let's just use them. For testing, we'll run. No, I mean, we'll just run all. For testing, we'll just run with the first image and see how the JSON and the JSON formation comes up. Yeah, runs the first image. It's okay. Table 909. Okay. Yeah. And I don't think it's requesting for any markdowns. So it's let's see. Let's see the code. if the model gets this right, if this approach works, then it's even more accurate for a lot of other figures. So uh, the entire this thing, any other, if JSON, there could be one, at least it could be 10 to 20% chance for each call the JSON might go wrong, but it's okay. Like you can't like you don't if then you have to use like OpenAI models. Doesn't make sense to use OpenAI models for this. If you want like accurate JSON, you can just do like a retry request in this, and hopefully the second one will work. And it's taking a long time. Shit. Yeah, it's not. It's actually invalid JSON, to be honest. Yeah, I expect this JSON will fail. 100% will not 100%. There's a good chance it will fail. And the max token output in JSON, it's not. I don't think it'll use 10,000 requests, but I don't know. Because it's a very complex table, and uh, let's try. Probably this will fail. If it fails, then we'll just go back to just revoke the code and go back to what we already had. Markdown was at least working, like it was at least working. So we'll go back to that. Now the thing is, we can easily go away with this capturing it as an image and sending it as what we deal with figures. We can basically assume this is a figure and then pass this as a context. But extracting tables is very important in rockets, like in all of these documents, because they're not like images. You can't like you can't assume things. Tables are very accurate with a lot of numbers. You deal with a lot of numbers, so because you deal with a lot of numbers, you have a structured format, and visually it's also available. You should be able to extract it. Right now it's in fact, we were able to extract most of the tables. This is such a complex table, and that's why we are sort of struggling. So let's see, there's another error again, one more error. Okay, full resolution is too large. Together times out the one switch to open router. Qwen works reliably. Or maybe maybe we switched the model. Maybe that's the reason. Oh yeah, that's why we get these hallucinations. We'll use another higher parameter model. We'll go back to, yeah, we'll do that and increase time up to 300. Yeah, we'll do all three. We'll do all three. Seems fine. Because it's not 100%. It's 1536 is okay, and I think we still see 1536. Actually, we don't, it's on downsize, we'll do 1 and 2, not 3. Let's see. Hopefully this should work, I think. Okay. And it's also in a high parameter model as well. Yeah. Hopefully this should work. And that's one of the reasons, maybe that's why the JSON output was wrong. I totally forgot we were using the smaller version of the model. Smaller version, I've tested it for simple tables, it's okay. For complex ones, it's hard. And plus also, again, you can still do the same thing. If it's a, you can do a lot of routing internally. If it's a huge, I mean, if it's like a, if you're dealing with complex tables, then you get a sample, send it to an LLM. If it's complex, then route it to the smaller model. If not the bigger model, you can do that as well. Yeah, I'm just trying to figure out if it works with one model, then you can do routing and all. It's a very simple stuff. That's not the hard part here. Like we are actually we're literally struggling right now to get this one single table right for this, and that's also a continued table across 4 tables. That's the hard part. But let's see. Hopefully, if this responds well, then that's good. It's open router, full resolution, and Alibaba, of course, the inference speeds are very slow. So we'll assume this takes around 6 minutes. Let me just go back, take my lunch, and come back. Alright, guys. Cool. I think it's success. Thank God. But we'll verify it. 38 rows, 15 columns extracted. Okay. We'll see that. No, what are you doing? Hey. Views the car later. Oh, I think it's still an inaccurate picture, guys. 38 rows by 15 column, headers captured accurately, JSON to Markdown with tabulate working. But where is it? Oh, okay, actually, I think it's working. Nice, yeah. Table 0, page 9. If I scroll up, you can see table 0, page 9. ID number 722, 723, 724, 723, 723, 724. You have 10. If I scroll, if I just make this big, you can see transition and you have unstable. I guess that's the stability classification. If I scroll down, you have 8216. If I scroll down, you have 8216. Nice. So this table is mostly accurate. Finally, we got it. This is coming from JSON. We can do the same thing for, and this is quite fast. I think it was quite fast as well. We'll do it for the other models as well. And yeah, looks good. 8216. Yeah, we'll run it through all the models. Yeah, run for all models. I want to verify that. But I think it's quite good. Yeah. The only thing that I can see is a very small sort of issue, which is again that line. So 30 is part of damp, not unstable. Unstable is above. It's only uh, yeah, yeah, it missed that very small thing. But I think at the end of the day, with this table, we can't get this table 100% accurate because not even Claude can get it. Like it's very hard for Claude. We'll enhance this later, but it is 90% accurate. What we only need is to pull this model, show it, and also show the image at the same time as well. Because we are anyway going to show the image, then it's good. We won't generate the markdown. This is just for context for searching, but we'll at the end of the day we'll show it as an image. So then the user, when the user were to click on any maybe the sources or whatever, maybe on the sides, I guess we should show the images as well, not just clicked on sources, but the image should be there and the user will verify that. And it's a very good spot for the correct, like good spot to correct system, because it's also in a point where you can't, even though you know it's 95%, it only works 95%, there's a gap in the 5%. No point wasting time right now in the 5% because there are higher problems to solve. When you solve that, you might hit to a point where it might give an inspiration, it might give you some info to solve this back or something like that. It's basically like a ripple effect. So 95% it's working, all good. Do not waste much time. We'll move for the next one. And yeah, oh shit, I'm just running it now. Cool, I think it should work. The first one got it right, the second one is also working. This feels mostly right except this 15 and undamped, or maybe even I'm even wrong. 30 doesn't have. Yeah, yeah, it's basically, yeah. Then the numbers on the chamber, yeah, that's a bit inaccurate. I can see that 00003, because of course it will be inaccurate because this is a very complex table, and unless you have a rule book or a ruler, like as physically a ruler, it's very hard to get it right. Of if not, what I will do next time is that I'll basically save this down, basically convert this table into a ruler. This will be like this is where I call custom pipelines, right? Where for this particular table, as I told you, we'll put a ruler, and instead of um, we know the headings, right? Percentage, contract ratio, a number of injection elements, static pressure. We know all of that. What we can do is that instead of sending the whole table, we can send this, and we can send only one line or five line, or maybe just an image, like a split of an image. Like the image would be split, so you wouldn't necessarily need to send the entire image. You just only need to send five rows, just a five one with all the split rows, and that's that 5% gap you want to solve, and that comes through custom programs. Like that's why general systems or general rack systems uh fail so much. You just can't use it, and especially domains like this, you just can't use it. You can literally see the amount of effort we're doing for just one table, one complex table, and there's still 5% to 10% of accuracy is still missing, because we're doing it with images. Okay, no problem, it's a good POC or a MVP system that even works with 10K docs, but it's okay. But you know that there is a gap, there's definitely a gap. That's why general systems work, and that's one of the reasons why even I built Intraplex, and we tend to even solve it on a very daily basis. We work with a lot of complex stuff and docs. I'll leave the link if you guys are interested, you can check it out. Cool. We'll see all tables, and we'll convert this to preview. And oh, finally, yeah, it works. Nice. I can see it's a number 6. Scroll down. Number 6, it's 8292. You have 8292, right? I have transition stable, and this mostly looks right. Let me see the number 8. 9.0. It's a clone for all of the same numbers: 9.0, 10.80, 8, 10.70. Okay. Okay. And what is, yeah, there's a small issue I can see in this number, specifically on 772. No, 772 is actually accurate. Not accurate. No, not accurate at all. 772, it should be 10.78, 7.8, and 10. It missed it. But yeah, at the end of the day, we are converting this table in order to send it as an image. So we are good to go. I won't say it's good to go. We still have things to solve, but this is a good start. Like we can start with this, send it as images, because let's say even if this table has an incorrect information, right? Um, yeah, it's true. Because some of the answers, it can't have information. It can't be inaccurate, because some of the answers could be it needs to be super accurate. You can't miss with this. This is a little bit inaccurate, to be honest here. Not so much, like 10% miss, so I would say like 10% ratio and a miss. Let's see the last one. Last one is 39. Yeah, last one is pretty accurate. And H2O got the same thing. And also if you're using a bit what I'll do is that I wanna see what Claude does, or how far can Claude process this. Because this could also be a domain, like a model problem. Like if Claude struggles, then Qwen, it's a 30 billion parameter model. It'll definitely struggle, and it's a very small model as well. So we'll say um, accurately. Okay, it'll fail. We'll just go to Gemini. Gemini will just it won't give proper answers, because it'll just skip, because the context is go. We'll just try it out. Convert this into an accurate markdown. Gemini did a good job. It's fine. It's totally okay. And 9 point, you can also see the numbers if I scroll down. You see, that's also still inaccurate. No, no, that's accurate. Number 14, no, it's super accurate. Very good. Yeah. Ours is is fourth one. Table 212. This is the last one. Table 212 image, I think. Yeah. And you have 14. You have maybe it's a JSON issue or something. I don't know actually. Actually, I think it could be a JSON issue. Yeah. The thing is, I would also want to support JSON as before as well. So I would like to support both. I can keep one of them turned on, but for now, add that JSON back if JSON mode, sorry, if Markdown mode is enabled, and then return the Markdown. For the next test, I want to return Markdowns. Okay, I want to check if Markdowns will be accurate enough or something. Yeah, so uh, I want to check Markdown because the thing is, at the end of the day, I would not never, I cannot really confirm what works until I test both of them. So unless I test both, it's very hard. Header format, that's okay. This is also okay. Yeah, that's what. If Markdown works, we'll just use Markdown. If JSON works, we'll use JSON. I can't still confirm because last time when I was doing something similar, we used Markdown and we used a different model. I don't think it's Qwen, it was something else. And it was a multi-model, it worked fine. And we had a different solution for tables. We couldn't extract it properly, not for everything. We did extract, but this, like, for example, something like this is something we convert it to an image and just give it. Now, why I'm trying to solve this in front of you guys is that you have to understand how, like sort of the pain. So this is quite even sort of new for me because we usually, if it's very complex, we rely into as into an image data or zoom it, crop it or whatever and just into the model. I'm trying to convert this into a table is because let's say in the future you want to do some sort of Excel operation or you want to do something when you have text-based content, you have to have text-based content because because or else it'll be just easy. Just you chunk the text. If it's something complex, then you put it store it as an image. That's not how it works. If you master this, if you master chunking this table, you'll automatically master most of the hard like most of the hard patterns across any documents you could see for this is quite even same thing on pharmaceutical companies have stuff like this, like not this complex to be honest. They have a more what do you call much more I won't say complex, but yeah, they have a lot of interconnected tables. So there's not one table. The tables are referenced towards other tables, but still, this is much more complex. Or we'll wait until okay, yeah, we'll write this code as well. Let it do, and if of course we've spent about 6 7 hours for this, but after this it should be easy. Figures are easy, images are very easy. I mean, there's no accuracy, right? In images, you just what you can't evaluate it. Like, you can evaluate tables easily. I mean, like hardly you can evaluate images. Um, so yeah, we'll just complete this code. I want to see the JSON, and if Markdown is better because we're using a different model, then we'll just stick with the Markdown. And I think I would also want to prompt the model to let's see. I want to tell Claude about this. Before that, this is an image of a table, a complex table. pasting the image. We want to prompt the model to even extract, if it's markdown, we want to prompt the model to extract each intricate parts of information, because when a table is very much complex, it should accurately uh, um, find the numbers that's related to it, rows that are related to that specific column, and not hallucinate anything or make up any information. We also need to we also need to understand, not understand, we also need to include like rows, like arrows and etc, uh, because those play a huge role in tables, in this schematics tables. Okay, we'll send this. I think image Claude is having some issues, so I don't think image will be processed. It'll give us an overload error. Oh no, it's working. Good. Yeah, exactly. So it has section dividers, arrows, multi-level headers, merge cells, chemical formulas, and dashes. All have to be captured, and that could only be possible in a Markdown. It's very tough for you to get on a JSON, and JSON will likely fail. And Markdown, even if it fails, you have the text. You can still chunk it. You don't need to do an API call. There's pros and cons. Easily, you'll have pros and cons, and I would say, yeah, easily both of the approaches will have pros and cons. It just depends on your solution. Do you like how many documents would have tables like this? In rocket stuff, more than 50%, 60% easily. So then it has to be solved. If it's finance, I wouldn't even care, because most of the stuff is from Excel, and they wouldn't have like they'll definitely have like financial tables, balance sheets, and etc. But it's not like it's very predictable. Most of them is very predictable, not so worse than this. Mm, yeah, so yeah, I don't think we'll use JSON. My gut is that we'll actually you go with Markdown, and I'll say for at this test I don't want to use JSON. I want to totally stick with Markdown, and I want you to uh, I want you to update the prompt for Markdown extraction prompt as well. I don't want JSON for now. I want to test Markdown. Oh shit. Okay, it has its own prompt there. That's hopefully, because batching it will complete in 2 or 3 minutes. Let's see. And of course, we discussed confidence scores. You have to have confidence scores for this. If I were you, I'll probably write. When I mean, like, if I were you, if I'm really designing it actual in a production setting, I'll probably write the confidence scoring right now, because we have time. I want to spend more time on something else. If not, I'll probably write the confidence scoring in this table itself, because if it's because you have to have confidence scoring for each sort of even in pre-processing flow. So a lot of people miss it, but pre-processing, let's say you pre-process a table, right? And then it might have any issues. But when you put in an information, the AI ranks the table, re-ranks it, and then gets the table and gives an answer. According to the AI, it's all the model is very right. We got the table, it's answering based on the sources. But what if the pre-processing answer itself has an issue? That's where even sources, or not sources, I would say, even like a lot of the evaluation frameworks, not even elaboration, even if the agent were to give a confidence score for itself, I did 90%. I think I did this. That's hallucination. It can even hallucinate the number. Like, you can't depend. You can't like LLM as a judge. That's the most. It's very good, but very stupid for a situation like this. Like an agent would actually read 50 documents, 60 documents, 70 documents, 80 documents, whatever, and then comes up with an answer. And then LLM as a judge, without reading anything, it'll just look at the question and say, ah, okay, seems like a good answer. Like you can't judge it. It's the most stupidest thing to do ever. So don't do that. I've seen most of the framework do that, like even do like encourage that. It's totally like it's totally one of the most stupidest ways of doing it. You shouldn't do it at all. What you should do instead is to, even though it's less less beautiful, you have to have confidence scores figured out for each thing, even for table processing. It's still custom. Like might tables might mess up. Then you need to have confidence scores for that, and then you have to weight it at the end. Agent's response, of course you can have LLM judge, but only for the response. The query, does it talk about the query, that's it. And then you have to have individual um what do you call, how can I call it, individual confidence scores for each and every process. Because if, for example, if this table got a confidence score of 50%, which is 50 to 60, that's a good number. Your final confidence score, when you weight it with agent's final response, will actually come low, and you'll flag this for easily automatically flag this for human review, right? So this is one accurate way of doing it. I just thought I should mention it because a lot of people just fall in, like, just really spend time on really unwanted stuff like that. But this is something you should pay attention to. Okay, now I think this is generated. um, okay, I can only see one. Okay, something has messed up over here as well. Shit. It has missed the first image. I don't know what's going on. It's completely complete. It's really an issue. Markdown is completely okay. Actually, ran it for one reason. Markdown seems to be completely wrong. Was it Markdown or JSON? Markdown is also being messed up. I want to see how many tokens. Yeah, we can use OpenAI take tokenizer. Just I know it's not accurate, but you can predict how much. Just 2,000, not even 3,000 tokens. It should be more than enough. Okay, so it's logging the raw response. We'll check the raw response and see. I would say in the meantime, without wasting any time, we'll actually start working on figures. I guess we have to do that because it's just doesn't make sense to work on this. I think we have one session already opened up. No, we don't. So we'll just do plot. And we'll select check the we are currently working on table extraction and we are 90% done. Make sure to check the development plan.md. And I want to parallelly work on let me see what's next. I guess it was formulas. Okay. Formula extraction. You can use most of the even formula extraction is often simple, so make sure to take inspiration from the table extraction. We probably will be using most of the code from it. Make sure to also check Docling's documentation, Docling's code that is already inside the public docs, and check how we could go about formula extraction. We would probably extract the formula, convert it to an image, and then send it to a VLM and get the accurate formula with notes. Okay, and I would, and this very formula is super simple. In fact, you can solve it in the next 30 minutes. We should be done with this. So we have table extraction going on and also that formula extraction. Formula. It is Markdown. It's still running. So let it run. That's also simple. It can detect. So it's not we are it's not so the thing is we are not detecting images, we're actually detecting formulas, and we crop the formula so we know it's a formula. And Docling has LaTeX conversion as well. I don't we don't The thing is it's very inaccurate. When I tested it, let's not use it. We'll definitely use, like Alibaba or whatever, like a Qwen model, and I think it should work easily. So um, uh, exact same thing, but then we find the formula and then send it and pre-process it and save it. Simple. Okay, we got the raw response. We'll check the raw response. It's actually hallucinating it. Parser is mangling it. The thing is, we don't need to parse it at all. Okay. I thought we were saving the raw response. Why should we should save the plugin. What parsing are we doing for the raw response? We want to we just want to save the raw response and not pass anything. We want it to accurately, um, yeah. Sorry, not really. Sorry guys, I'm a bit off. Just response. Because we want to save it as raw as possible. We want to save the raw response. And is this the raw response or response after response, raw response, or the formatted response? But I think, yeah, we're doing some formatting. Maybe that's the thing. Yeah, so this is correct, I think. 100% correct or not, I don't know. We shouldn't have any parsing going on for this. We'll actually convert this into an MD file. I don't know how accurate this is. I'll just give it to GPT. Okay. Okay, we have Claude is working. Let's see this. Okay, I'll give this. We'll probably create a markdown. And Claude has done an awesome job. Just see the table, guys. It's so accurate. No issues, nothing whatsoever. 100% accurate. Yeah, that's the. Uh, I mean, it's a high intelligent model, right? And also parsing and stuff, Claude is very good at. That's why it's like when you work with open source models, it's actually such a pain. Um, um, like it'll generate so many mm, random, s- so random stuff. It might even generate like Sleeping Beauty stories or something when you put a table. You would never know. Even small, like very small models, easily does that sort of stuff. You can't 100% shoot that. But I think this extraction was right. So let's see. And also, this is doing a lot of cleanup and only giving this information. Quinn is yeah, probably dancing. I don't know what. No, we'll actually use some other model. We'll switch to a different model, I think. Yeah. I don't think we have to stick with Qwen. We'll actually use something best. Higher parameter VL model. This is highly inaccurate, like highly inaccurate. Like these lines are highly inaccurate. Like these are like really made up information sort of thing. Uh, we'll actually use a higher VL model, I would say. We'll go with we'll try Qwen, but a higher VL model. Right now we're using third. No, we'll use a model maybe. Uh, yeah, we'll go with this one. Yeah, we'll use this model. Okay, so this is the code I think for formula extraction. Extract formulas from PDF. It's using PDF for options, pipeline options. You have the input part. Okay. Scale still 2.0. It's the highest, I guess, highest resolution cropped image. You can still expand it, but yeah, no point just unnaturally expanding it if it's the same. There's two ways you can crop it, or you can still stick with the same resolution. You can reduce the resolution and also increase the crop size. Um, yeah, whatever. But this code looks good, but we'll know whether it's working or not in the testing. So we'll see. Yeah, cool. It's simple. It's simple. I just want to test the first image and I want to directly see the raw response of the model. And also, I would say before you do that, just remove any no. I think this is also a prompting issue, guys. I think it's a huge issue in prompting as well. I think, yeah, what we should do. And also, just for the sake of this, simply update the prompt temporarily, saying convert this table into, sorry, convert this image into an accurate table. That's it. This way we know whether it's a prompting issue or maybe if it's actually failing or what is really happening, because I think we added prompts on markers and etc, and that's what it's trying to do. Maybe it's assuming we have to add markers for everything and it's adding markers for everything. Maybe that's the case, but we will see this. And uh, yeah, so yeah, table and pngs in there, it's okay. uh, great wheel formula processor. So critical requirement accuracy is paramount. Extract every symbol, script, output, valid LaTeX. Yeah. Greek all notations. Actually, I would say this is such a we're just killing the entire prompt. Like we're just overcomplicating it. We just have to say that do not invent any information. And if you were to give like engineering notation, specific impulse, trust to weight, mass to flow, you're not encouraging it to use the domain intuition, and it'll sleep on your prompt. And if something comes up, and you just basically it'll basically reconstruct the same thing to what you mentioned on the prompt, and you it'll just do it. So I'll approve it to now. And I would say, I'll just stop it and say, keep the prompt dead simple. Tell it to not hallucinate any information. Use the context above, context before, and the formula, and accurately, yeah, present it, output it, and leave, and also give notes that cannot be things that involve nuances or cannot be explained through a formula or your output. Capital 50 words. That is enough for now. You don't need all of those complex prompting at all for this. And still it's complicating this, guys. Like, see, variables, equation type, notes, and all of this stuff. Do not complicate it. Once again, it just needs the model needs to output the equation only with notes. That's it. No need of equation type, no need of variables, just a LaTeX display or the equation type, just the equation. Like you don't need variables, and then you have to match the variables, and then matching fails, and then that's another issue. You just don't need anything. I actually think there's some issue with parsing. It's taking so much time. It shouldn't take this much of time. Doesn't mean convert just convert this to a markdown table. Cool, that's it we want. And I think there's an issue with this. put tables this image. Go to Markdown accurately. Oh, maybe guys, we need to rotate the image. That's the thing. See what is yeah, this is correct, I think. Yeah. I see a lot of these are spaces generated. I don't know why these spaces are generated. You know, we'll actually stick with JSON and we'll accept the minor issues. Hopefully the model should solve the JSON. We'll just accept the minor issues, to be honest. And here we have the text. Yeah, this is better. To be honest, this is way better. We'll run Markdown preview with this and 7772. This no figure number is wrong. Figure number is shit. I just hallucinated like crazy. Stable, unstable, unstable, unstable. Damn, that's okay. But we got the figure number wrong. Or maybe it's a different, the same table, different number. Shit. What shall we do? Let's see how Claude gets to 772, right? I think Claude should accurately do it. Convert this to a markdown accurately. I mean, of course, it'll be accurate. If that's the case, then we can use Claude, but basically, yeah, the whole idea is to get it running on an open source model. Yeah, even after we changed this model, the above 3 billion model worked very well. It was very well. This is also wrong, completely wrong. But this I can see Claude is doing a good job. Let's try the same thing with JSON. Actually, I don't want JSON because it's very tough. If a single JSON string fails, and the whole JSON will go off. Tables are, at least it gives you entire tables. See, this Claude has given like super, like so accurate stuff. I think as far as I can see. Yeah, yeah, this got 100% right. See, unstable, unstable. There's unstable, unstable, and then 30, right? And it has unstable, unstable, and then it has 30. Good stuff. Got it accurate. Get it super accurate. But like, what is the current state of the art? Best VLM. I repeat, best VLM. Because Claude did a amazing job. So we're using the 2.5 VL model, I think. I hallucinate a lot. I think this is different image. There's hallucinates a lot, like transition, and there's nothing, but yeah, it just made up some more information. I think this model did a good job as well. Copy the code and verify it. Just preview that. Preview that. It hallucinated 5 instead of 3, and you can see 772. It's 10.8. That's okay. Yeah, it has messed up a little as well. What? And let's say Claude, it's 3. Claude got it right. Okay. Okay, guys, I guess time is limited. I have a meeting in 1 hour, so I have to pause it in. To be honest, I have to pause it in 1 hour, or maybe in 45 minutes. So what I'll do is that we'll we'll continue this tomorrow. Then. So the same thing with JSON. We'll use this particular model. It seems to do best. Uh, Something decent apart from any open source models. We'll go with this, and this is only this issue is only for complex tables, right? Not for other tables. Other tables, 70 to 80% of the times you have not so complex tables, at least 50, 60, easily more than 50, I would say. So let's use also prompt the model to understand the image and create accurate table markdown, and it doesn't need to type out extra spaces, or like we need to specify the model to understand it and create an accurate markdown. It doesn't need to accurately follow all the space structures or spaces at the end. It basically needs to formalize it and create an accurate representation of the table and still be effective as well. Do you understand what I'm trying to say? Oops. Do you understand what I'm trying to say? Like it can, because visually it might hallucinate this is what a visual image would look like, but that's not what we want. What we want is to get an accurate content only makes sense. The format of the markdown doesn't matter as long as it resembles the exact content or the table, and also encourage it to get rid of any extra spaces and just make it more efficient and accurate. Cool. Okay, I think it's you. Yeah, this one. I think temperature we can give that. Okay, keep temperature at 0.75 and increase the max tokens for 20,000. I mean, of course, it's just 2,000 bridges. Okay, let's see what response we get. Mm, Extra formulas. Okay, it's just an additional helper function. Let's actually test it out and let's use this model. This is more than enough for formulas. So it's very small, not complex at all. Use V and V. Formulas. There was one document for formulas. I had this one. Guess it was table. Okay, ton of formulas. It was four. Yeah, this one. You can see a lot of formulas, right? Let's use this. I think the table is gonna fail today as well, for sure. Because it's taken more than 2 to 3 minutes. It's a very simple table. Claude just gave it in less than a minute. So it's gonna fail for sure. It's okay. And process formulas. Oh, okay, yeah. It got the formulas very right. This it messed up. I'm not happy with one of them. This one is not accurate, I think. Yeah, this is accurate. This is accurate. This is also accurate. This is not accurate. Not accurate at all. How I want to know more about formulas. The formula, how does the formula extraction happens? Is there any other model that we can use for formula detection? I think there's a different model we can use. I think I did something before on this. Yeah, that's getting unwanted output cells. Usually should not be the case. No, generated thousands of empty cells. Yeah, exactly. So formal detection task 2, layout model detection. And stage 2, code formula. For this enrichment, we're using VLM, so we don't need to care about it. Let's use this model. Yeah, let's use this for detection. Let's use this for detection instead. That's why you see this cropping stuff going on here. And yeah, then if we were to use this, probably you'll get the entire formula. It should be accurate. Okay, so I'm gonna pause this on because I don't think I can complete this table. So what I'll do is that from tomorrow we'll go in upside down where we'll actually fix everything and then come back to tables at the last. Okay, hopefully we can figure out tables tomorrow. Figure out this specific table. Others are okay. This is very complex. Run it. Okay, detected 11 formulas. We'll actually cross-reference. We'll just cross-check it. I think it could be right, could not be right. We will never know. We'll never know. So we'll just see the images. Uh, this is one. 2, 3, 4, 5, 6, 7. Actually, 6 to be honest. It could be the entire formula. It is the entire formula. 6, you have 7, you have 8, you have 9. Where the hell is 9? Okay, 9, whatever, 10, 11. Yeah, you have around. With that, if you see, we need to be able to see all of these formulas. It shows 11. I think it should be right with index 0, but we'll verify it one more time. Oops. Okay, the processing is not yet there. Okay, we'll process it. But we can see it using this VLM instructions. So what I'll do is that just give this to Claude, convert it properly. I should give me like a visual view on it. So because I don't want to miss find time or just miss my time with this. So we'll see. So this is the start of the no. Okay, okay, yeah, it's right. Actually, there's this formula, I think, but still, that's so different. We might not need it. It's fine. It's part of the symbols. We'll actually, even though if it's okay if we don't capture this because we'll actually capture this part of symbols. So tomorrow we'll work on symbols. We'll work on what not formulas. Formulas are nearly solved, I think. We'll work on the rest. So we'll verify this. This equation, yes, got it right. This second one, yes. This wait, this is the second one, I think. Wait. This is the first one. It is right, I think. Second one. Okay, it has missed this airflow. It has missed this particular formula. Not sure why, but we'll see why it does. This is right, and this is right, and this entire formula is also right. The big one is right, and then this and this, both of this is right. If I scroll down, f equals to f scale plus delta c, that is also right. If I scroll down, there's equation 8. GRTCCV gives something. Okay, so it has assumed this is the only formula. Okay, it has basically yeah, that's wrong. That's definitely wrong. And you have final formula. Okay, it has missed a lot of formulas. Shit. But it's okay. It's a good starting point. These are the images. It's just a large model. And is there any configs or settings for formula extraction? Check the code accurately and let me know what can we tune, what can you not tune. Because currently it doesn't capture all the formulas, and also the screenshots or the crop is very inaccurate. We'll just dig deep into how the layout for formula processing actually happens. This is very inaccurate. But hopefully, yeah, it's a probably like a configuration sort of thing. We can figure it out. Yeah. Okay, there are configs. Tunable settings, layout. Oops. Where is it? Formula extractor can change the model. Layout options. Keep empty close. Padding is the problem. Yeah. Not tunable. Hardcode is in Docling. Yeah, we can pass this. I think it should be fine, and it should give an accurate image capture of the formula. So let's see. At worst case, guys, what we can do is that, let's say, I mean, at the end of the day, it detects that this particular whatever, for example, this is a formula, this is not a formula, whatever, right? Detects it's a formula. We can see that's right. So what we can do is that expand it, like increase the padding and just capture this specific information. I mean, this image, if it doesn't yield a lot of results, we can just capture this particular image. It's a little bit more of visual text, a little bit more of actual, like, sizable computable context, but you will still end up with an accurate formula. That's what we want. Like, we want to prioritize accuracy over here. Okay, then that's still yeah, that's basically, that is a workaround for it as well. But let's see. And table, I guess we can solve it. For some reason, I'm not in a good mood to solve this, so we'll just skip it. Tomorrow I can check back on this later, but let's see. And yes, you can see it did capture. Where is it? The initial formula, I think. I don't know where this formula is coming from. M0. Okay, the first one. Okay, so I think we should increase the padding. It's right. That specific location is 100% right. And the second one too, we can just skip that. That's not a uh, that's not a formula, of course. And the second one, WG, I guess it missed it. Okay. This is okay, but still, that is okay. This is good. This is good. Still misses the entire point. Like, see the where is it? FJ scale, that's still missing the entire point. The third formula misses a lot, so much. We'll do this. We need to be able to accurately capture the formulas. Hence, we know where the formulas are, right? So then what we'll do is that we'll expand or capture uh, the image should be the, let's not we'll just use the information or the bounding boxes or whatever the location information from Docling, and then we'll basically try to access the entire formula. Even text is captured, it's totally okay, we just need to get the entire formula. So what we'll do is that we'll capture the entire horizontal and also a good chunk part of the above what do you call vertical aspect as well. So it's probably like a landscape pic, uh, and the formula will definitely be captured in that. Or do you have any other ideas? Yeah, we'll try this and see. Now, in worst case, what we can do is that because formulas are so important, we can, I mean, an image cost is like nearly, it's not a big difference. We can just send the entire image. If you detect the formula, then you send the entire image to the model, and whatever formulas do exist, the model will return all the formulas. It's not very efficient, but it's also, we should prioritize accuracy and use LLMs as much as possible. So it's also one of the good ways of doing it, I think. Yeah. So let's see if this works, then fine. If not, we're gonna detect, okay, if there's a table, if there's a formula, we'll send the entire page to the model and it should easily, I think that's even better. I would say that's the best approach to do. We'll just go with it, I would say. Let's see, let's check this, and if it doesn't work, we'll go with the full page approach. And that's also, for example, if like we're probably making 13 or 14 requests, right? If there's like 5 formulas in a page, we make 5 requests, and adjacent formulas might be confused. We just capture the entire page, send it. Simple but also very effective. You just get all the formulas back. Of course, detection is done by the EC3 large model from Docling, but parsing is done by a VLLM. And yeah, yeah. Yeah, we'll come to table tomorrow, to be honest. I guess this would definitely work because we're capturing horizontal, the full horizontal aspect, and also vertical. Usually formulas, you won't have formulas that's, like a paragraph long. Usually I don't think so. And if you were to have like methods written, then it's a different scenario. We can capture the entire image. That'll still be the most accurate way of doing it, but we'll see this. Now we'll see this image. Yeah, so you can see 100% accurate. But still, okay, this works. This is also good. This is good. This is good. This is good. Good. This is also good. This is good. This is good. This is good. This is also good. This is fine. This is fine. Not the best. And exactly, did miss a lot of formulas as well. It missed all of these formulas. I guess better we'll just do like the page approach. Yeah, because we cannot afford to lose anything. What I would say is that this is fine. This is fine, but we'll have one. Sorry. This is fine, but what I want to do is that because this needs to be very accurate, if we detect a formula on a page, we basically send the entire screenshot of the high resolution page to the model and get all the formulas back. So whatever page we detect the formula, we send all of those pages and get all the formulas back. We'll do it for now. We should have done this before. But the thing is, the good thing is that you'll have all the references. For example, like let's say, like see this formula, and then you see where this was obtained from a charts of reference 8 and the static pressure parameter of this formula. This will be literally captured. That's proper context, right? And the notes will actually complete. Will actually, what do you call it? The notes will actually capture this as well. That's additional context. So yeah, of course we'll waste money in tokens. Not an issue at all. We just need accuracy here. Cool. I think this will work nice. This will work like piece of cake. Let me check what we have left. Uh, yeah, we look 80, 70 to 80% done with this. No, this is done. Parsing is done. Table extraction is 70% done. This should be done now. Picture diagrams, the same thing. Hierarchical structure, we don't do anything. It's part of Docling. So yeah, tomorrow we should complete this thing and move into the agent, and maybe try to complete the agent. And the third day we'll do the entire evaluation, and then wrap it up. Like, I want to quickly check if this is the same issue with simple tables as well. What is this document? This is man. Okay. I want to check if this is the same with small tables or basic tables as well. So can you process this document? 812 180. Yeah, we don't need much of time. It's output as an array, formulas, data. Okay, yeah, it should. We need an array because you might have a couple of formulas, right? So it's okay. Yeah, run this. So this is the image, I think. Correct. This is right. Yeah, this is right. Yeah, I think for simple tables, it's working well. We just need to increase the padding a little bit. No, I just want to make sure that it doesn't just it's there's no any issues with the code or whatever. Like, we'll test this, and I think this time formula should work. Yeah, we'll check this. Okay, so output for PDF images. So okay, so this works. You can easily see that's the results. If I expand this, you can see. So simple tables are very, yeah, that's nothing to be honest. You can even like very basic models. So this is a challenge. We have to get it somehow working for tomorrow. I'll brainstorm after today's live stream if I can get it, if I can come up with any new ways of solving for that specific table. I think we can. And 12 formulas I extracted was 11, which is very correct. We did see there was actually 12 formulas. So this is an entire formula because we're capturing the page. It gives us an accurate representation of the formula summary, and we'll send this to Claude now. Okay, first one verified, second one verified, yes. Third one verified, yes. Fourth one verified, fifth one verified, yes. Sixth one verified, and also this got very correct. So, and I guess there's also notes, so that's okay. That's correct. Okay, we left it at 6. Then okay, we got formulas. We left it at, I guess, 8, 6. Sixth one is correct. Seventh one is correct. Eighth formula is also correct. Eighth formula is also correct. Equation 8. It's very correct. And then I guess there's more formulas. 10, 11, 12. Okay, and the final formula is this one. 12. That is also correct. And I think we also have notes. Okay, not a big deal. We can just generate notes for them. I think it does generate notes. All 12 captures. That's what we want. Like, even though you spend like extra dollars, doesn't matter. Plus, first of all of the stuff will be deployed inside the company. You're talking like 5 to 10 minutes of a difference for processing. That's it. You can, and you should do it. And yeah, this is accurate. So we'll deal with this complex table tomorrow. I'm wrapping up this live stream already 7 hours plus. Um, um, yeah, yeah. I didn't anticipate that it'll take a lot of time for this table, but yeah, but that's what I want to do. Like take a lot of time and figure things out. And we'll solve table tomorrow. At the end, we'll finish. Yeah, formulas are working. That's good. And we'll complete the rest of the yeah. What do we have? We have images still not really hard, but it's also not like not straightforward as well, because you see there's like images across different pages, stuff like that. And then you have what do we have? Development plan. You have formulas that's done, picture diagram, hierarchical chunking, and then embedding. And afterwards, yeah, you will figure it out tomorrow morning. Awesome. Thanks for watching this, guys. Yeah. I'll leave the repo once all of this stuff is done. Like once we improve this, we're gonna like it's not just one thing. We're gonna back and forth, come back and test it and evaluate. And like I would say, like when we test it is where we'll know where it goes wrong, and then we'll definitely come back and touch the pre-processing. We'll again touch. So nothing is like it's not written on the wall. You probably have to, come back, change things up, and modify depending where the AI goes wrong. But this is just a basement. Trying to build a basement. Okay, awesome. Thanks, guys. See you in the next live stream. Bye.